Once again, hello everyone and good afternoon. Welcome to the Energy Consciousness Month culminating event. I am Yasmin and I am your Master of Ceremonies for this afternoon. Before we proceed with the program, we would like to announce that we will be having our raffle sponsored by the IIEE 3 Expo throughout the program, and we will be giving away 3 pieces IIEE notebook with pouch, 3 pieces gray IIEE polo shirt, and the grand prize will be 1 piece mountain bike. So now, as we move along, without further ado, to officially open this ceremony, please welcome the Chairman of the IIEE Energy Efficiency and Conservation Committee, Engineer Christopher T. Bellaflor. Uh, unmute your... sir, we cannot hear you po. Nakamute po, Sir Perry.
Hindi pa
Ayan.
pala ako
Yes, sir.
Okay.
Okay,
So medyo
sir.
napaaga-aga tayo So anyway, thank you very much, Yas, for opening the event. So also, thank you very much to all the attendees sa culminating event ng Energy Consciousness Month celebration. First time na ginawa natin sa IIEE. So just a small information. So the Energy Consciousness Month actually is a proclamation during the time of President Gloria Macapagal-Arroyo proclaiming the month of December as the Energy Consciousness Month by the DOE, by the Department of Energy. So it will be, since IIE is now actively participating, especially sa RA 11285 signing, the new law. So naplano ng Energy Efficiency Committee, Conservation Committee na i-celebrate din ng IIEE ang Energy Consciousness Month. So it's been a really challenging time sa atin sa IIEE, especially sa amin sa Energy Efficiency and Conservation Committee. So ang Energy Efficiency Conservation Committees actually a revival lang. So ngayon lang ulit binuhay ang committee ito, and we're just an ad hoc committee. Hopefully later on will be a regular committee ng IIEE. So today again is a culminating event of the celebration of Energy Consciousness Month. But hopefully it will not be the end of your participation and practice to the energy efficiency and conservation. So tuloy-tuloy lang. So sabi nga, 'di ba, tagline ng RA 11285, make energy efficiency and conservation our way of life. So also, it will be a culminating activity para sa committee na ito. And I would like to take this opportunity to thank the committee members ng Energy Efficiency and Conservation Committee. And of course, the 2020 officers, national officers, for trusting yours truly to head the committee. Okay? So puro culminate ang pag-uusapan natin dito. And with this, we will culminate the celebration with sharing of 3 best practices in terms of energy efficiency and conservation. So we have invited 3 speakers na mag-share ng kanilang best practices. So throughout the year, since February, yes. So we've been presenting we've been having seminars on energy management system, other chapters. Ang hit nating seminars related to energy is solar, di ba? Now we will be giving you some inputs sa mga in-place practices na ng mga colleagues natin dito sa IIEE. They are all IIEE members, and licensed electrical practitioner, one coming from the food industry, another one coming from the shopping malls and commercial establishments, and another presenter will be coming from hospital, and actually previously from semicon industry. So maganda yung mga makukuha natin dito, and I hope na marami kayong mapulot. And we will be having a special presentation then with our favorite celebrity entertainer, diba? Kay Lana Roy. So supposed to be she's supposed to be presenting last kick-off natin during the expo, pero nagkaroon ng emergency, and swerte naman natin sa culminating event, meron tayong special presentation ulit from Lana Roy. And of course, sabi nga ni Ma'am Yas, so meron tayong raffle, di ba? And related to energy efficiency, ang ipaparapol natin. So fuel economy, di ba? Kesa gumamit tayo ng ating sasakyan, so we will be raffling one mountain bike. So sino kaya? So sana yun, dumadami tayo. Akala ko hindi dadami ang participants eh. So sino kaya magiging napakaswerte dahil isa lang ipaparapol nating mountain bike. And again, thank you very much for gracing us with your time para umattend for this culminating event at para matuto rin sa ating mga colleagues and energy practitioners na in-invite natin. So with that, I would like to officially open ang ating culminating event, and I would like to turn over the virtual floor to Ma'am Yas. Ma'am Yas, thank you.
What a way to kick off this event. Thank you very much for your warm and informative opening speech, Sir Perry. Okay. As we move along, let us all get ready to meet our first research speaker for this afternoon. He is a registered professional engineer with more than 16 years of experience in project management, construction, plant maintenance, and industrial automation. He gained his expertise while working from various multinational and local companies. He was an instrumentation instructor at the Meralco Foundation Institute, project manager at Linde Philippines, electrical and instrumentation site engineer at the Unilever Philippines, engineering and maintenance management at Netlex Development Corporation, and he is currently the technical services manager of Monde Nissan Corporation. To discuss Best Energy Practice 1, Household Products Manufacturing, let us all welcome Engineer Rodel Manalo.
Thank you, Yas.
Hi.
Good afternoon, everyone.
Good afternoon, sir.
Pwede na ba ako mag-share ng screen ko?
Hi. Yes, sir.
Okay. Teka ha. Okay. Teka lang ha. Nahanap ko lang. Ayun. Okay. Okay, so good afternoon. Good afternoon, everyone. No? Okay. Okay. No? So clear naman ako, Yas?
Yes, sir. We can hear you
Okay.
clearly po.
Malinaw, sir.
And okay, so I will be discussing energy practices which I have gained no through my experiences with various companies that I have been with. No, but particularly ito during my stay at Unilever. No, and then after that, yung yung shinare ko rin dun sa mga companies na napuntahan ko. Okay, so it started my EE journey starts no yung energy efficiency journey sometime 2014 no when the Department of Energy through UNIDO and PIEEP no so they are looking for 40 new national experts on energy management system no so based from ISO 50001 so yung mga ibang slides ko dito are derived from the UNIDO ENMS expert training. Nakita ko rin yung ito nung once na-invite namin si Press Perry no in the NLC webinar in one of our GMMs no? So I would start with this slide no so ayan so this is the ISO 50001 Energy Management Standard Framework. Although itong pinapakita ko sa inyo is developed similar to the PDCA, almost similar no to the PDCA concept. So pinapakita dito no that for your energy efficiency program or your energy management system to work, it should have the 6 key concepts. No? So ano ito? No? You have number 1, commitment. No? So first and foremost, dapat there should be management commitment no? to implement the energy management system. No? So it defines the roles and responsibilities. Okay. So you have the SEUs or yung tinatawag nating mga significant energy users. So based from your Pareto, no, so ma-determine mo doon what are your top siguro top 10 no top 10 biggest electricity or energy consumers in the plant. No? So kahit top 10 lang, no? So you do a Pareto study, so kuha ka ng top 10, so yun yung SEUs mo. And then you define your energy performance indicators. So, also yung tinatawag natin na ENPIs. So halimbawa, sa with Unilever, kami palagi doon. We always based if your if our manufacturing or our production system is very effective, no? Uh, Pagdating sa energy, we measure it in terms of the, let's say, kilowatt hour per ton, no? Or kaya in terms of steam, so kilogram of steam per ton of output. So palaging gano'n, no? Yung ENPIs namin. And then from there, you develop your opportunities list, no? Okay, and then you do operational control, and then you do again. After that, you do review, no? So yung ENMS hindi yan hindi yan one shot. Ano yan, it's a continuous process. So para yung EE journey mo tuloy-tuloy, and then your company will reap the benefit of your energy efficiency programs or yung energy management system mo. Okay. So sabi natin, no, first and foremost, there should be a commitment, no? So ayan, sinasabi diyan is the management responsibility. So any programs, halimbawa, ang frustrating sa mga energy managers or energy advocates, no, especially if you're in the industry, yung wala kang support, no? Kasi paano mo wala kang support from the management. Kasi mahal yung mga no, mahal yung mga energy efficient equipment, no? So halimbawa, if you would implement yung mga for motors, let's say high efficiency motors, mahal ang mga high efficiency motors as compared sa mga standard motors. So halimbawa gagamit ka ng mga variable speed drives, no? So kaya kailangan you have the management commitment, no? So dapat isusupport nila itong journey na to, no? So will they make the necessary resources available, so both technical, financial, and yung mga personnel, no? And this is a decision point, no, in any ENMS system, kasi nga very crucial yung first part na ito, no, yung management responsibility. Kung wala kang makuhang support, hindi magiging successful yung energy management or any energy efficiency program na pinaplano mo. Okay. And then you should have a policy, no? Okay. So more than just the signature, no, yung sa management commitment natin, dapat naka-define dun yung scope ng ENMS mo, no? And yung commitment to continual improvement, no? So kaya dapat may mga resources, no, na available for your energy efficiency projects. Okay. So this is an example of an energy management policy, no, when we drafted nung sometime 2014. Pwede naman halimbawa isang section ng manufacturing plant or pwedeng yung buong company, no. During that time, isang section ng planta lang yung in-applyan namin ng energy management system. Okay. Ayan. And then you go planning, no. So gaano ba karaming energy ang ginagamit natin, no? Saan natin 'to ginagamit, no? Sino yung pinakamalaking user? Kaya nga sabi natin kanina doon, no, ina-identify natin yung mga significant energy users natin, no, SEU. So you do a Pareto, so biggest consumers ng energy mo. So dun yung i-attack natin kagad, no, kasi dun siguro sa top 10 na yon, no, most probably yun yung pinakamalaking gain na makukuha natin kagad, no? So ano ba yung nagde-drive, no, dun sa paggamit natin ng energy? So in our case, manufacturing yun, no? So manufacturing of basic goods, no? Okay. So ano yung base load? No, so importante rin natin malaman 'yan, no? Ano ba yung base load mo? Para kung wala kang production, hindi naman necessary zero ang energy consumption mo, because you have some utilities used, no, to store your products, So wala kang manufacturing, but you have to keep yung mga finished goods mo protected, no? So gumagamit ka ng at least small amount of energy, and that is what you call base load, no? So sino bang nag-i-influence, no? So yung gamit ba ng tao, yung makina, no? Okay. And there should be an energy audit, no? So kami noon every year we do energy audit pagdating sa electricity. Meron kaming siyempre manufacturing, no, so may compressed air, so energy audit ng compressed air and boilers, no, so yun yung mga energy audit na ginagawa namin noon, no? And then we do also system optimization. So dito ka nakakakuha ng mas malaking benefit, no, or mas malaking gain, no, as compared to yung mga install ka lang ng BFD, install ka ng LED lights, no, or maglalagay ka lang ng high efficiency motors, no? Okay. So if you have if the company can afford, no, so meron din mga renewable energy options. So usong-uso ngayon, no, yung mga companies na naglalagay ng solar energy, no. So yung company where I belong right now, yung Mondinisen, no, it has sa solar sa roof niya, no, so meron dong nakakabit na mga solar panels which is about 1.3 megawatts, no. So ganun yung company, nag-invest siya into renewable energy, no. And then we develop baseline and indicators, no, we set objectives and targets, and then yung action plan. Okay. No? So after that, after the planning, no, we now go to implementation and operation. No? So diyan na pumapasok yung mga training, no? So competency ng mga tao, so awareness in terms of the energy efficiency. At that time, no, kahit naman ngayon, no, lahat ng mga multinational companies and even the local companies, ano na tayo aware na tayo sa effect, no, ng climate change. So kaya medyo in talaga ngayon itong mga energy efficiency, no? Okay. No? So syempre we document, no, our programs, no? We do operational controls, no? So including yung iba pwedeng kung hindi mo expertise ang boiler operation, so you get an energy service contractor, no? So kasi merong mga companies na yun talaga yung kanilang yung kanilang expertise, yan yung mga ESCO, no? So they will operate your utilities, no? So whether it be steam or compressed air, and then they would assure you of a certain return on investment or yung reduction in your energy consumption. Okay. And then mahalaga dyan din, syempre yung training, no? Okay. So we provide training to our employees, to our maintenance technicians, no? To our engineers, and also to our operators. No? Okay. So importante rin that if you are into new plants, no? So during project stage pa lang, doon maganda i-implement na kagad yung mga energy efficient design, no? Okay. No? And kung hindi naman, so dapat if you would be purchasing new equipment, so kasama natin dapat yung procurement department or yung purchasing department, kasi dapat lahat ng bibili natin should be energy efficient equipment na, no? So yung mga equipment, machines, services, and goods should all be geared toward energy efficient equipment and machines. No? Okay. And then after that, we do the checking, no? So tama ba naman yung ginawa natin, no? Okay. So diyan na pumapasok yung monitoring natin and targeting, no? So nung sa Unilever, we implemented, no, yung tinatawag nating MMT program noon. Or hanggang ngayon meron sila, no, which is called metering, measurement, and targeting, no? So mini-measure mo, so nag-install ka ng mga meters and then nagta-target ka, no? So meron dong mga based from your base load. So halimbawa during weekends, so meron kaming sinet na dapat ito lang ang consumption ng factory dahil walang operation, no? So pagka tumataas, no, lumalagpas doon sa sinet na target, so pinag-aaralan 'yon, bakit, no? So baka may mga naiwanan na utilities, no, may naiwanan na compressor. So nag-iikot yung mga technicians and engineers to check, no, just to ensure that the energy consumption is based dun sa sinet namin na targets, no? Okay. So diyan din pumapasok yung system checking, no? So lahat ba ay ginagawa kung ano yung dapat gawin, no? So diyan na rin pumapasok yung mga corrective and preventive actions pagdating sa paggamit ng mga utilities, no? So energy, no? Okay. And then we do performance checking, no? So yung tinatawag natin na yung mga energy performance indicators. So weekly, no? So mimitingan 'yan, no? So gumagawa yung production namin ng ano yung output nila, and then the utility department will provide the consumption, no? So tapos based from the ENPI. So chine-check, no, whether they are below or above the performance indicators. And then after that, we again do management reviews, no. So may mga regular presentations kami, no. Yung frequency based on the requirements, no, kasi yung global, no, may target eh, no. At during that time yung Unilever is around 2015 naging signatory siya dun sa Paris Treaty, no. So kaya nire-report namin, no, sa global ano yung energy consumptions namin on an annual basis, no. Okay, tapos kung merong mga off targets, so pinapagawan kami ng mga ways and means to bring again the energy consumption to the baseline, no. Okay, so diyan din pinag-uusapan, so ano yung plano natin for next year, no. So ano yung kailangan natin ma-achieve para aagawin para ma-achieve natin yung plano, no. There was a time, no, nung yung Unilever company gusto niya magkaroon siya ng uh, carbon neutral, no, mag-carbon zero siya, no. So malaking malaking task sa amin 'yon kasi siyempre heavy electricity user, heavy sa diesel din, no, kasi may boiler yung company, no. Okay. So journey 'yon, no. Hindi naman 'yon kaagad na tatapos nung year na ibinaba 'yon. But when I left, no, yung Unilever, all of the electricity for all the plants naka-source yun sa isang renewable energy source. So at least dun sa isang aspect na yon na tupad, no, yung ambition na yon, yung aspirations. Okay. No? And then after that, no, you start all over again, no, kasi sabi nga hindi ito project no, hindi ito one time na pagka na-install mo na yung BFD or nakapaglagay ka na ng machine efficient na motor, tapos na kaagad, no. So journey yan, no, kasi dapat kailangan makita year on year bumababa yung energy consumption, no? So yun ang talagang proof na effective yung mga energy management programs and systems na in-apply mo, including yung mga projects, no. Okay. Okay. No? So I would share to you some of the best practices, no. So ano ba yung mga ginawa namin noon, no? So yung Unilever being a lean company, no. So although it doesn't follow yung Six Sigma, no, meron siyang tinatawag na world-class manufacturing, no. So yung isang pillar kasi doon, yung environment pillar, no. So meron dong mga ways and means, no, on how to reduce, no, or implement yung mga energy efficiency, no. So at ang unang-una doon, no, you should create an energy balance, no. So ano ba ibig sabihin no? So ibig sabihin noon gumagawa kami ng halimbawa mula sa source, let's say electricity, no. So from the source, from Meralco, saan pumupunta yung mga kuryente, no? So pwede kang gumawa ng kahit na flow chart, no, paano ba dumadalo yung kuryente from the source up to the equipment, no. So para makita mo, no, saan ba tayo pwedeng saan ba tayo pwedeng mag-apply ng energy efficiency program, no. Okay. Parang ito naman, no, so gumagawa ka rin for for gas, no? We create an energy balance for gas at saka for compressed air. No? So dito makikita mo, no, yung kung paano yung from the compressor pumupunta sa mga machines, no? Okay. So this is an example of an energy balance for electricity. So yung MECO, yun yung Meralco, no? So from Meralco, paano ba pumupunta yung mga yung electricity? So paano dumadalo yan up to the actuators, to the equipment, no? Okay. So mula sa mga substations, no? So papunta dun sa equipment, etc. So nung dumating ako sa Paco noon, merong ano, no, merong 1 2 3 apat na accounts ng from apat na Meralco accounts, no, yung isang site, no, yung Paco site ng Unilever, no. So yung so na so magtataka ka, no, bakit apat, no? Eh siguro nung time na yon, before, no, dahil isa sa mga big consumers din ng Meralco or customer ang Unilever, so na-allow, no. So yung pinaka main plant may dalawang substation yon, no. Tapos merong isang manufacturing plant na biglang kinailangan ng power, no. So imbis na ikabit dun sa substation, naglagay na lang ng panibagong service. Tapos yun namang isang building, yung sa marketing, yun, marketing and R&D. So ganun din, no? So another service. So hindi siya nakakonect sa main substation diyan sa WSS at saka sa ESS, no? So those are the west substation and the east substation. Eh itong substation na to, nakapasok ito sa nung 2013 naipasok ito sa open access, no. So siyempre yung nakakabit doon sa substation na yon nagbe-benefit na sa murang energy ng brought about by the open access. So naiwan yung commissary and yung isang building, no. So ang ginawa namin, no, to save on electricity cost and kasi siyempre may losses, hindi naman masyadong loaded yung transformer noon at that time. Nasa mga 50% lang yung loading ng transformer. Alam natin, medyo mababa yun, no? So hindi efficient yung gamit mo dun sa transformer. So ginawa namin, minove namin yung commissary at saka yung building na yon to the substation. So kinonect na namin doon. So hindi ka na nakasave ka na sa electricity cost, no? Okay? Kasi open access yung connection nung west substation and the east substation. At the same time na load mo pa yung transformer mo, no. Naging mas efficient pa yung operation ng mga transformer mo, no. So kung wala yung energy balance na yun, or itong diagram na to, no, so hindi mo makikita yon, no. So hindi yun makikita nung bagong mga electrical engineers. Okay? Or kahit na yung mga dati, no. Okay. No? So isa rin doon nga sa sinasabi natin kanina, no, yung base load. So dinidetermine namin yung base load, no. So inaalam namin, halimbawa from ano ba yung electricity consumption ng manufacturing plant, no. In this case may sample ako, no, yung deodorants factory, no. So ano yung during a typical manufacturing day, so let's say Monday to Saturday, so ano yung kanyang average consumption, tapos ano yung kanyang maximum, no, na consumption. So inaalam namin yan. And halimbawa walang manufacturing walang production, let's say Sunday, no? So ano yung minimum electricity consumption nung planta, no? So ayan, ginagawa namin 'yan para nga 'di ba malaman natin, no? So let's say baka kasi minsan yung mga operators, no, nakakalimutan nilang patayin yung compressor on a Saturday evening after the manufacturing or after the production. So pagdating ng Sunday, wala nang production pero yung compressor takbo ng takbo, no? So wala na nakapansin, no? So kaya inaalam namin yung base load. So pag nakita yan ng utilities department o bakit through our metering, no, dun sa MMT software namin, so pupunta siya kagad dun sa site and then he would check all the equipment, no, if it is switch off. So may list siya ng mga equipment na dapat naka-on at dapat naka-off, no? So yun yung purpose bakit ka gumagawa ng base load, no? Okay, no? So sa lean manufacturing kasi may tinatawag na 7 types of energy losses, no? Uh, so from the energy source to the point of use, no, and kung may transformation ka, yung mga transformers mo, uh, distribution line, no, to the point of use, bawat habang nagta-travel yung ating electricity, no, so may mga losses tayo diyan, no. So halimbawa sa energy source, ano ba ang loss natin diyan? So pwede tayong magkaroon ng tinatawag na yung type 7, yung energy source loss. So halimbawa, ngayon lahat tayo gumagamit ng we rely on the electricity provided by our distribution company. So wala namang problema 'yon, no? So pero meron tayong alternative sources We can use ayan, 'di ba, yung solar natin, no? So for other companies, so nakikita nila yung benefit ng solar, so they invest, no? So may iba rin they invest, no? Siguro although very typical, no, sa mga manufacturing company, yun ang investment, yung solar, no? Previously may nag-offer sa amin ng wind power, no? So kasi nakita niya harap nung Pasig River So nakita niya merong potential, no, for magkabit ng wind vane, no? So wind itong wind power, no? Pero hindi nag-progress kasi masyado pang mahal, no? Okay. So sa transmission naman, no, or sa transformation, meron tayong yung type 5 and type 6 losses diyan, no. So yung power factor, no, harmonic distortion, no? So meron kang mga leakages, no. So insulation, let's say kung steam, no, so or chilled water, no. Okay, and then meron din naman mga technical efficiency, no? So type 6 transformation loss. So dito na pumapasok yung mga use of let's say high efficient motors, no? Okay. And then sa point of use, meron tayong 4 types of losses, no? So yung type 1 to type 4, no? So ano ba yung type 1? So sinasabi natin useless consumption, no? So meron din naman tayong tinatawag type 2 overconsumption, type 3 non-optimization, and type 4 not using recoverable, no? So halimbawa useless consumption. So ano ba 'yon, no? So meron kaming mga areas before na kahit walang tao, halimbawa comfort rooms, no, naka-on yung ilaw, naka-on yung mga exhaust fan, no. So pwede nating gawan yun ng project, no. So pwede tayong maglagay ng mga naglagay kami no ng mga motion sensors. So pag walang tao sa comfort rooms or sa mga hallways or sa mga meeting rooms, so automatic i-off niya yung ilaw, i-off niya yung aircon, no, etc. Okay. So yung type 2 naman, yung overconsumption, no? So yung mga ibang tao gagawin nila, no, yung pagdating sa office, so i-on yung air conditioning unit, isi-set kagad sa 17 degrees kasi masyadong naiinitan, no. Tapos hanggang ano na yun, hanggang maghapon na yun, no. So kaya minsan makita mo yung mga ibang tao naka-jacket kasi ginaw na eh. 'Di ba? Pwede naman pwede tayong magtipid sa kuryente doon, no? So kaya ginagawa namin noon, kinuha namin lahat ng remote control, no, ng mga hindi kasi naka-centralize yung yung air conditioning unit no. So kinuha namin yung control ng bawat air conditioning unit, and then kami na ang mayroong isang technician na part ng trabaho niya, so umikot para buksan, no. So bubuksan niya yon 30 minutes before the office time, and then 30 minutes after end of work, no. So pinapatay na yung aircon. So tapos enough na yon to cool to cool the room, no. So at isa pa rin yon na program rin kasama with the HR department para mabigyan yung mga tao ng work-life balance, kasi minsan yung mga iba sa opisina na natutulog no. Sobrang workaholic. So sa amin ginagawa namin noon, basta pagdating ng 6:30, no, 5 o'clock, no, mga ganon, depende kung ano yung office hours nung building na yon, pinapatay na yung aircon, no. And then mapipilitin ka ngayon, no. So lalabas ka na talaga after nung office hours, no, nung building na yon. Okay, and then lights off, no, pagdating ng hard anong talaga yon, hard lights off na kagad yon, no. So papatayan ka ng ilaw, so alis ka na kagad, no? So non-optimization, no? So yung type 3 and yung type 4 not using recoverable, no? So yung non-optimization naman, yung sinasabi natin dito na yung pwede nating mga gawing programs, no? Let's say sa manufacturing plant namin nakalagay halimbawa for a particular machine, sabi ng OEM dapat ang nare-receive ko lang na ang cooling temperature ko nagre-range, no, pwede ako from 15 degrees to 20 degrees centigrade, no. So yun yung setting, pero ginagawa ng operator para masigurado niyang hindi nagkakaroon ng offshoot, no, dun sa mga product or dun sa system niya, no. Either kasi minsan naiiwanan, no, o hindi nababantayan ng mabuti. So isi-set niya ngayon yun isi-set niya yun mas mababa pa sa 15 degrees centigrade, no. So okay naman yun. Ang problema mo siyempre kumukonsumo ka ng mas malaking kuryente, no. Okay? Kasi takbo ng takbo yung chiller namin para i-sustain yung lower temperature na hindi naman required nung OEM, no. So kaya iyon, tinitingnan namin yung mga ganong klaseng losses, no. So pumapatak yun dun sa ino-optimize namin siya, no. Okay. And then type 4 not using recoverable, no. So ito naman kung meron kang mga halimbawa sa steam, sa boiler namin noon, meron kaming mga recovery system, no. So yung sa air compressors, meron kaming mga nire-recover namin yung heat, no. So ginagamit para painitin, no, yun namang mga hot water na ginagamit sa mga shower areas, so sa mga CR, no. So this is an example, no. Halimbawa yan, sa isang project namin doon, nakita namin, no, meron kaming isang motor, no, several times nang na-rewind. So yung efficiency hindi na alam kung ano, no? Okay? So this is a type 6 loss, no? So gagamit ka na ng ano, no, ng mas better na technology. So gumamit kami ng mga energy efficient motors. So mapataas natin yung efficiency niya, and at the same time mapapababa natin yung kanyang energy consumption, no? So or pwede rin tayo maglagay ng variable frequency drives, no? Or instead of using an indirect drive, baka pwedeng direct drive na lang, no, yung motor natin dun sa kanyang load. For example, sa mga cooling towers, no? Okay. No. So ayan, tinitingnan din namin yung at kino-correct yung power factor, no, correction, kasi dun kanina sa 7 types of losses, no, sa transformation, no. So oops, hindi ko pala nabago, no. So dapat ano yan, so yung power factor, no. So chine-check namin yung mga capacitor namin kung in good condition pa, and then we replaced pagka ano na siya, no, pagka needs replacement na siya, no. Okay, so from 0.88 ayan na gawa to 0.97. Okay. No? Okay. So this is a typical example also of an optimization of equipment, no. So yung type 3 loss naman. So meron doon, kadalasan kasi sa manufacturing minsan, no, pagka biglaan ang mga projects, no, hindi mo na mahintay yung na purchase na motor or na equipment, kung ano na lang yung nasa warehouse, no. So there was once an equipment that needed a motor, no. So instead of using a 6 kilowatt motor, ang ginamit yung mas malaki kasi yun yung available, no, the 28 kilowatt. Tapos dahil nga masyadong malakas yung flow ng product, no, papunta doon sa ano niya, doon sa next process. So nagto-throttle ka na lang ng mga valve, no. So yun na lang ang ginagawa mo, no, i-throttle mo na lang yung valve para yung flow papunta sa next process makontrol mo, no. So nakokontrol mo yung flow, tama yung flow papunta sa next process, pero yung electricity na nako-consume mo masyadong mataas, no. Okay? So hindi optimized yung gamit, no. Okay? So pwede rin naman, no. Okay? Pwede rin naman kabitan mo ng variable frequency drive, no? Pero bakit mo kakabitan ng variable frequency drive if in the first place ang solution mo is to replace it with a smaller sized motor, no? So marami niyan, no, marami niyan sa mga planta, ganyan ang kadalasan, no? Kung ano na lang kasi yung makita, no, yan ang readily available, o sige kabit na natin yan, no. Okay? No? For compressors, no, it's ang kadalasan ang ginagawa, no, kami rin na guilty rin diyan, no. So isang compressor for all, no, for all equipment. So halimbawa and then siniset mo yung pressure setting nung compressor dun sa machine na merong mataas na requirement ng pressure, no. So let's say may isa kang equipment 7 bars. So yun na yung nagiging ano mo, no, nagiging system pressure mo all throughout. So yun naman pala, meron kang mga machines that would only require 4 bars, no, or kaya lower than yung system pressure mo na 7 bars. If you would ask yung any, no, compressor expert, no, in terms of yung system optimization, no, may mga ganyan din si DOE, no. So sasabihin niya sa inyo na pag ni-reduce mo yung pressure by 1 bar, no, you reduce also the energy consumed by 7%, no? So mataas 'yun. Biruin mo kung kailangan mo lang pala 4 bars. Eh dahil nga isa lang yung system mo, 7 bars, so you are losing 21%, no, of energy para lang ibaba, no? So i-reduce to 4. So yung iba ang ginagawa, meron silang dedicated air compressors for low pressure equipment, or kaya naman iba rin for those high pressure equipment, no? Okay. So tapos yung mga iba na ginagawa namin, no, gumagamit din kami ng mga automatic drains for filters, dryers, and tanks to avoid loss of air, no. Tapos yung system, no, yung piping system namin ginagawa naming ring, no. So para nadi-distribute evenly, no. Okay. And then we provide adequate ventilation for compressor room, no. So mas mainit kasi ang sinasak na air ng mga compressor natin, mas mataas ang energy na kinokonsume niya. Okay. So for boilers, no. So ito naman yung ginagawa, no, namin, no. So naglalagay kami ng mga economizer or air preheater, no. So use in boiler system for heat recovery. So meron ka kagad dyan in terms of efficiency improvement, nasa 4% na kagad dyan, no? So tapos gumagamit ng mga variable speed drive for combustion fans, no, induced draft fan, and boiler fuel feeders. So ang savings mo kagad dyan nasa 10%, no, on energy, no, so electricity and fuel, no. So use of automatic blowdown and thermal insulation. So yan, palagi yan, no, chine-check yung insulation ng piping to ensure that hindi nag-escape yung steam or yung heat, no. So nami-maintain mo. Okay. No. So according to it is a proven fact, no, na proper system insulation saves approximately 6%, no. Okay. So of thermal energy, no. No. Okay. So and this will be my last slide. So sa UNIDO, no, palagi nilang ang education nila would always be a system approach in terms of energy efficiency at hindi yung component approach lang, no. So halimbawa, ano ba yung sinasabi natin sa component approach? Ayun nga, magkakabit ka lang ng variable frequency drive, no, or magpapalit ka ng high efficient motors or high efficient chillers or compressors with variable speed drives, no. So okay. So it is true na may gain, no, pero normally pagka component lang, individual component, ang gain mo lang diyan mga 2 to 5%, no. Whereas if you would study, no, the whole system, no, so system approach ang titingnan natin, it would bring about a maximum of 30% efficiency gain, no. So kaya it is better that when you are implementing mga energy efficiency program, you look into the whole system, no. So yun nga, mga examples na ibinigay kanina, no. Halimbawa, yung lowering down of temperature, lowering down of pressure, no, without or opening of valves, no. So hindi mo siya tino-throttle. So instead of installing itong mga individual components, so mas mataas yung nagiging gain if the approach to energy efficiency is more of the system approach. Okay. Okay. So thank you and good luck on your energy management journey.
Okay. Thank you very much, Engineer Rodel, for for gracing us na ma-share yung mga energy practices. So, wala. Okay ba? You can hear me?
Yes.
Okay. So anyway, we are now open for question and answer. And also, not only question, pati mga inquiry. Kung mayroon kayong gustong inquire na in-install na mga equipment ng mga presenter, pwede nyo i-inquire. So anyway, we will go on with our first question. Sir, in your from Ronnie Acception. Sir, in your management review, gumagamit po ba kayo look ahead schedule for whole year? What do you mean on-off schedule? Sorry po, paputol-putol ang dating niyo rito. Okay.
Okay.
Yun.
No? Oh, so siyempre during start of the year, gumagawa kasi ng budget di ba? So naisasubmit mo sa head office or dun sa may-ari So nakalagay doon ano yung annual volume production, no? And then tatapatan mo 'yon, no? So ano ba, may ganito kang annual production, ano ang cost natin pagdating sa electricity, pagdating sa fuel, no? So or kung ano pang mga energy ang ginagamit mo. So ginagawa 'yon, no? Okay. So yung scheduling, no, yung kanina yung isang tanong naman, no, what do you mean on off schedule, no? So inaalam namin dun sa production, dapat sinasabi niya kagad pagdating sa halimbawa hindi siya tatakbo dahil meron siyang raw material problem, no, or kaya may issue sa packaging material, no. So ina-advise niya kagad yung utilities department para yung utilities either patayin niya yung electricity papunta doon sa mga equipment na yon, or yung supply of air, supply of steam, no? So para nakakatipid ka, no? Kasi hindi na nga nagpo-produce yung makina and yet gumagastos yung kumpanya mo ng utilities. Isa sa mga malalaking cost, no, ng manufacturing, no, in terms of yung cost ng production is the cost of utilities, no. So kaya gumagawa ka ng schedule mo, no. Tapos dapat katulong mo yung production para alam mo kung pag wala silang production, shut off lahat ng utilities. So save ka sa energy. Save ka rin sa production cost.
Okay. So, is there any other question? So, medyo maganda yata sobra yung presentation ni Engineer Rodel Kaya walang tatanong. Parang na-overwhelm yata ang ating mga participants sa ganda ng mga energy practices. Anyway, actually, I've been practicing energy management also at dami ko ring nakuha sa presentation ni Sir Rodel. So, Sir Gilbert Guevara, nag-raise ka ng hand kanina. So, aksidente ba or pa-type na lang sa Q&A, medyo restricted yata ngayon. Ang video, allowing video. Yan. Okay? Any more questions? Okay. So, if none, so I will turn over the virtual floor to our secretariat, Sir Brian, for the presentation of the certificate.
Good afternoon. The Institute of Integrated Electrical Engineers of the Philippines Incorporated Energy Efficiency and Conservation Committee presents this Certificate of Appreciation to Engineer Adelito Manalo for imparting valuable insights as resource speaker on the topic Best Energy Practice, Food Manufacturing, giving this 12th day of December 2020, Philippines. Signed by Christopher Villaflor, Chairman of the Energy Efficiency and Conservation Committee, and Rodrigo T. Picolera, the 2020 IIEE National President.
Thank you.
Okay. Thank you very much to Engineer Manalo for sharing to us your valuable knowledge. Now, from one remarkable speaker to another. He graduated BSEE from Lyceum of the Philippines, Manila. He is a professional electrical engineer and the Assistant Vice President to Operation of SMETD. He is also the 2020 Metro South Chapter President and the Vice Chairman of the IIEE Energy Efficiency and Conservation Committee. To discuss the best energy practice, number 2, for shopping mall, let us all welcome Engineer Charles Singson. Let's give him a round of applause.
Yes, good afternoon. Thank you for the wonderful introduction.
Good afternoon, Sir Charles.
Afternoon, sir.
Yeah, clear ba? Clear ba ako?
Yes,
Yes,
sir.
sir.
We can hear you.
Pwede ba mag-back out? Kasi ang galing ang ganda ng boses ni Engineer Manalo eh.
Mas maganda yung voice mo, Charles.
Okay. Anyway, this is my first time to use itong what do you call Zoom. Nasanay kami sa MS Teams. Pero I believe pareho lang naman yung pag-share. So,
Yeah.
paano ba ikanto? I-share. Okay, sandali I will share. Hindi na ako mag-video para hindi kumain na ng data.
Okay lang.
Okay. Jasmine, paano ko ba i-share to?
Sir, nakikita niyo pa ba sa baba, sir, may share screen po na nakasulat na icon. Color green po.
Okay. Okay. For a moment. Okay, nakikita na ba?
Yes, sir. We can see
Yes, we
the
can.
presentation now, sir.
Okay, that's great. Okay, thank you. Wonderful afternoon to everyone. So let me first thank our chairman, Perry Villaflor, for inviting me to share with you our best practices on energy efficiency and conservation strategies. If Chairman Perry still recalls, kung sharp pa yung mind niya, I know, very sharp pa yan. Bata-bata pa eh. We are both one of the chosen recipients of the prestigious DOE Don Avelio Award, Energy Efficiency Awards on 2008. Dear Perry, natatanda mo ba yan? That was 20 years ago. Batang-bata pa kami ni Chairman Perry noon, and he represented Toshiba Information Equipment Philippines Inc. Okay, let us have muna siguro icebreaker. So I believe all of you have GCash. Lahat ba may GCash?
Hindi.
Sir.
Meron.
Yes, okay. So I will put 1,000 in your GCash if you can answer my question nearly right. Okay? Because I would like to test how good are you when it comes to estimate or guesstimate. So I believe all of you have already seen or visited Mall of Asia. So this is my question. Chairman Perry, wag ka nang sumama rito. Alam mo na to eh. So question is, what is the average demand, kilowatt demand of Mall of Asia? So anyone, you may type your answer in our message box. Ano yung kilowatt demand ng Mall of Asia?
From Hajid bin Damao, 4 mega. Gilbert Guevara, 50 meg.
Okay. Okay. Chairman, please help me find who have gotten the correct answer. Then, siguro, isend mo na lang sa akin, i-text yung details
Alright,
ng
okay,
GCash
okay.
so that I could deposit. Okay.
So
The
yung
correct,
unang nag-type ng tamang sagot kasi ba magkapare-pareho.
yes, so the correct answer is 16.5 megawatt. Tingnan mo na lang kung sino yung pinakamalapit. 16.5 megawatt.
Wala na magta-type. 10.2, 12.
Wala.
Wala.
12, 20. Yung 12 ang pinakamalapit, mas mababa. Or higher is 20.
Okay, tingnan mo na lang kung sino yung pinakamalapit doon. Tapos, just send me the details of the GCash para ma-deposit natin.
Alright, okay.
Okay, thank you. So, to proceed, maybe I will give you a first very quick background dun sa Enercon natin. Yung sinasamahan namin lagi ni Chairman. Ito, busy siya rito, yung RA 11285. So, which is already be implemented by next quarter 1 of 2021. Okay? I have simplified my presentation by giving you tips of our actual practices, yung strategies of our energy efficiency programs. Okay. Matagal mag-change to pa. Okay. Okay. So, little quick background dito is signed by President on April 12, 2019. Tapos naglabas na ng memorandum si DOE. So, nag-start to nung naglabas si DILG ng memo. Tapos, yun, sumunod na si DOE. So, ang direction is to submit, yung nasa baba, yung Annual Energy Utilization Report, yung Annual Energy Efficiency and Conservation Report, saka yung appointment of designated energy conservation officers and energy managers. Okay, dapat this year pero in-extend nila, ang submittal is not later than April 15, 2021 na. So ready na ba lahat dito? Yung mga attendees na designated establishment, ready na kayo for this preparation of report? So hope so. Okay, so ito lang yung pinaka-kanya, contents of the law. Okay, so I highlighted, emphasized yung mga related sa atin. So which is yung demand side management, incentives, yung professional competency and services, and designated and other establishment. And of course, yung prohibited acts and enforcement na nakakatakot dahil ang laki ng penalty na pwede ka pang ikulong. Okay? Okay. So, what are the responsibilities of yung Certified Energy Conservation Officer and Certified Energy Managers? Okay, to manage the energy consumption, to administer the programs, and other responsibilities under the Act, saka yung IRR implementation. Okay, so papasok dito, meron ding mag-guide sa atin, yung ESCO, kung gusto nating mag-hire ng ESCO to assist us on the technical, managerial, audit, design, and financing. Okay. So, designated and other establishment. Okay. Break nila into type 1, type 2, and other establishment. Yung type 1, okay, those annual energy consumptions na merong 500 kilowatt hour or 4 million kilowatt hour per year. Okay? Pag i-relate mo siya sa monthly billing, pag sa commercial or yung mall, ito yung kanya relation niya sa commercial billing. 333,000 to 2.6 million per year. Monthly. Per month pala yan. Per month na. So yung type 2 mo is those building na annual energy consumption of more than 4 million kilowatt hour. Okay? So per year yan. So pag i-relate mo sa naman sa commercial, yung may monthly billing na 2.67 million and up, covered na siya, under na siya sa type 2. Okay? Other establishment are those consuming 100,000 to 500,000. So pag i-relate mo dun sa peso again, that is 66,000 to 333,000. Nung chine-check ko yung mga Jollibee, famous Jollibee and McDonald's, they are under this other establishment. Kasi Jollibee and McDo, they are consuming 200 something to 300 kilowatt hour. Okay? Ito naman, pag relate mo yung 4 million kilowatt hour, that would equate to less than 1 megawatt, 847 kilowatt. Okay? So 8 hours ko na to, 8 hours operation. Yung 500 kilowatt hour naman, that is 105 kilowatt. So masyadong mababa pero covered ka na dun sa law. Okay? Okay. Next. Okay, obligation of designated establishment, yun na yung online registration, online submission of reports, energy management system, okay, program for EEC and RE, target, record consumption, energy audit. So ito yung obligation ng designated establishment. So lahat ng building is a designated establishment. Okay? Okay. So mukhang yung pan ko hindi na nag-operate yung animation. Okay. So energy efficiency and conservation practices. Ano ba yung reason? First, yung left na illustration is to help yung world to lessen or to reduce yung carbon emission natin. Okay? So is there an efficiency good for business? Is energy efficiency good for business? Yes. Ito, hiniram ko lang itong presentation, yung efficiency investment, risks and returns. I do not know kung saan ko nahiram to. Basta may presentation, kinopya ko lang, linagay ko na rito. So, this shows na, ang example dito ng illustration na to, when you go to small stocks or common stocks, masyadong mataas yung risk. Mataas yung risk, pero yung annual return mo is mababa. Pero please try to see yung energy efficiency na programs. Yung risk mo, if you invest on that, yung risk mo is mababa, pero yung average annual return mo is mataas. Okay? Okay. Okay, so balik tayo sa Mall of Asia. Okay? The mall has an average demand of 16,546 kilowatt. That would equate to 7.1 million kilowatt hour per month. Pag in-equate mo into peso, that is 57 million per month. Okay, for that alone, makapag-reduce ka lang ng 10%, you have a cost avoidance of 5.7 pesos per month. Okay, that is 68.4 per year. So, i-duplicate mo lang lahat sa building mo to. So, ang gandang investment, di ba? So, yes, energy efficiency is good for business. Tapos, magandang investment. Kung may pera ka, i-invest mo for the energy efficiency, maganda yung return. Okay? Okay, how can we do it? Okay, first, you should know your energy consumption. Okay? So, on the right illustration, ito yung monitor namin. So yung 2019 that is color blue and 2020 is yung orange, okay? During 2019 this December, so ang taas ng consumption. Pero with this 2020 bababa because of yung result ng pandemic natin. So there are still businesses inside the mall na hindi pa open, like yung cinema, yung mga palaruan ng mga bata, among others, even yung mga ibang tenants ayaw pa mag-open. Okay? So, on the left side, yung below, na graph, that is comparison naman for the 2019 versus 2020. As you can see, yung January to February, ang taas ng consumption ng 2020. Pero nung nag-pandemic na tayo, nauso yung mga lockdown, yan, bumagsak na. So, till now, mukhang ang tagal baka maka-recover ng energy demand o yung natin consumption. Even Meralco, parang hirap na hirap sila. Pangit daw yung business ngayon, sinasabi ni Meralco. Dahil malaki din yung nawawala sa kanila. Okay. Okay. Of course, you should know your billing determinants or yung billing mismo. Okay. With this presentation, yung left side mo, that is an actual bill. Okay. So that is September 2018. So ang bill is 11.8 million. Okay. So, yun, pinapakita lang dito ni Meralco na ang distribution ni Meralco, the total bill is, ang share lang ni Meralco for that is 5.29% lang daw. Okay? Ang malaki talaga is on generation, 65.61%. So tama yung sinasabi ni Meralco na taga-singil lang kami. So, pero sila nabubugbog. Okay, that's the reason why na ang sarap maglaro ngayon sa open access, yung retail electricity supplier, dahil ang laki yung pinaglalaroan mo, you're playing with the 65.61%. Okay? So, yung mga billing determinants natin, okay, there is an active, yung kilowatt hour mo, yung demand mo, kilowatt, reactive, yung reactive energy mo. So, those determinants has been used or they are using for to compute for your billing. Okay? Okay, load profile. Manufacturing, yan ang load profile ng manufacturing. Nasa taas. Tapos yung load profile of the semiconductors, yan ang ganda rin. Di ba nakikita niyo ang ganda ng load factor ng manufacturing and semiconductors. Ang ganda ng load factor nila. Pero pagdating sa commercial, okay, ang pangit ng load factor ng commercial. Sa umaga, mataas yung demand, pero sa gabi, wala. Okay? Yung nasa right side, yung bottom, yung green na graph, that is an actual profile of one of our building. Okay? So, yan, nakikita mo profile na may yung maximum and minimum. Yung maximum yung kulay orange, yung minimum yung kulay blue. So, yun, sa gabi, wala ka talagang load ko konti. Okay. So again, for the left side, balik tayo sa left side, yung sa billing determinants kanina, pinakita yung energy, reactive, and demand. Okay. But for this billing, as you can see, the load factor is 60.96. Mababa yan. Pag kinompare mo sa manufacturing, semicon, mataas ang load factor nila. Baka 70, 80. So what is the impact of load factor? Yung nasa taas mo, na right side, that is the formula of load factor. Okay? Kilowatt hour divided by 24 times maximum demand times number of days. Okay? So, balik ka sa yung billing mo, yung energy mo is 1,478,750. Divide mo lang sa 24 hours times yung demand mo times 31 days. Okay. Sa load factor mo na 60.96, the effective rate is 8.0 peso per kilowatt hour. Okay? So this presentation wala nang kinalaman sa energy efficiency natin kasi load factor. Pero yung best practices may kinalaman pa rin. Okay. If you want to correct or improve your load factor, okay, this is the tip. Pero pag meron kang mixed use na project, may commercial ka, may BPO ka, okay, what you will do is mag-isang metering ka lang. Wag mong paghiwalayan yung metering mo. So 1 meter, magre-request ka sa DU that you will be needing 1 meter to cater yung commercial and BPO. Okay? So that yung load factor mo is mag-improve. Balik tayo sa load factor profile. Yung highlight ko ng red, pag meron ka ng BPO or may load ka sa gabi, okay, so tataas yung energy mo at the same demand. So ang load factor mo, pag kinompute mo ngayon using the formula, ang load factor mo is 74.21%. Ang magiging effective rate mo, pag sinimulate mo yan, is 7.72 pesos per kilowatt hour. So yun, may kinalaman yung load factor dun sa effective rate. May mga buildings kami na magaganda load factor, mas maganda yung rate, mas mababa. Okay? Next, yun, ito na, yung mga tip. Okay. Tip number 1, dun sa air conditioning system, you need to know the background of the ACBS energy use. Okay? So, yung pie na to, pinapakita rito yung consumption ng AHU and fans, that is 65%. Then yung chiller, cooling tower, condenser, water pumps, that is 8%. And yung chilled water pumps, yun, mas mataas pa yung chilled water pumps ko kaysa yung mga chiller, cooling tower. Dahil kung minsan yung mga designer, mataas ang tataas ng head na require for their calculation. So it would affect yung system mo, yung energy mo mas mataas kung hindi tama yung pagka-compute ng mga heads of the pumps. Okay? So every building air conditioning system has parameters that can be controlled, disturbances that are beyond our control, and temperature, humidity criteria that we must maintain in these spaces. Okay? Yung right na graph, yung three-dimensional profile, parang represent nito is a valley. Okay? So, meron dyan yung X1, yan yung set point mo, temperature set point mo for the chilled water. Okay? Yung X2 mo, that is yung set point mo for the supply air temperature. Tapos yung E, that is the energy required para ma-meet mo yung temperature, humidity criteria of your spaces. Okay. Ang target mo dapat dito is to achieve yung pinaka mababang valley, which is yung green. So what will you do? So yan, yung optimization yung gagawin mo. So medyo mahabang process until makuha mo yung tamang mixture or timpla para makuha mo yung green valley. So that is the best that is the best optimized energy that you can have for the building pag nakuha mo yan. Okay? Okay. So ano yung mga strategy na pwedeng gawin? So yan, conversion of your large AHUs to variable air volume capacity control, and the conversion of the chilled water system to variable flow with all AHUs, pumps. So via installation of BSD. And of course, yung plant integration mo to fully functional enhanced BMS system. Okay? So, ang problema kasi, kung minsan meron tayong BMS pero hindi nagagamit ng tama. So sayang. So you should make it fully functional para ma-achieve natin yung energy most efficient energy in our building. Okay? So the next is yung optimized operation of the entire ACBS to make the fullest use to maintain comfort and energy efficiency. Okay? So why BSD? Okay? So BSD because the relation between the revolution of the fan and the pump impeller and the power consumed is cube. Okay? Yung affinity law, yung graph dito sa left side, that is affinity law. Makikita mo yung graph sa yung fan and impeller curve on the right side, yung power versus speed. Na power is proportional to the cube of the speed mo. So at full speed, the power is 100%. Okay? Pero pag binabaan mo yung RPM mo, yung speed mo, example 80%, the power will be yung cube, di ba? 0.8 times 0.8 times 0.8, that is 51.2% of the power consumption. Okay? Yung gitna na presentation that represents yung energy consumption mo versus the speed. As an example, meron kang 30 horsepower na fan running at 90% of its speed. So i-cube mo lang yon, 0.9 times 0.9 times 0.9, that is 73%. Mumultiply mo lang sa 30 HP mo. So the consumption is 21.9 HP. Okay? So yan ang maganda sa paggamit ng BFD because it is a cube of yung power mo, cube of yung RPM mo sa affinity law. On the right side, advantage of BFD, kung ano yung rated current mo during startup, yun lang yung makakonsume mo for the starting of your motor. So very important, kung nagde-demand side management ka, BFD can be a big help also. Okay? So another one is yung best efficiency point. Okay? You should find the best efficiency point of a motor because this can provide you a 3 to 4% efficiency increase. So that is again an energy reduction. Okay? Yung left na graph, okay? Ang pinapakita rito, yung flow mo versus yung efficiency mo. Yung best efficiency point is at the flow of Q2. That with an 83% efficiency, okay? Ang laro lang dito is plus minus 10. Kasi pag bumaba ka masyado, hindi ka na efficient, tapos may effect dun sa operation mo. Pag pumunta ka naman sa far right, ganoon din. Dito, yung pinapakita ng effect ng operation of best efficiency point, yung right graph natin, na meron kang best efficiency point, pero pag pumunta ka sa left side, yung higher head, yung kang magkakaroon ng mga high temp rise, low bearing seal life, okay? Yung suction recirculation, meron kang reduced impeller life, meron kang low flow cavitation. Pag pumunta ka naman sa low head, high flow, yan naman yung mangyari, yung low bearing seal life. Okay? So hanapin lang yung best efficiency point. Meron naman sa kanya, pag bumili kayo ng mga pumps, you should get yung mga literature doon sa mga suppliers. Then discuss with them on how to do it, how to get the best efficiency point. Okay? Okay, yung pump curve, okay, every time na bumili ka ng pumps, hanapin mo yung pump curve. Okay? So for this example, this was used for the secondary pump of the air conditioning system sa chiller side. The flow is 2400 GPM, yung head niya is 140 feet. Okay? So pag i-graph mo yan, hanapin mo yung 2400 GPM, so that is doon sa yung sa vertical, that is 2.4. That is the 2400 GPM. Tapos doon sa horizontal na yung red, that is 140 feet. Okay? Dito nangyayari yung pag nag-over design, ang tataas ng head, so yan, magiging inefficient ka na for that. So dito, pag ang pumps mo is mga centrifugal, pwede kang gumamit ng BFD. Okay? So, yung system intersected data dito sa right side, pag 2400 at 140 feet, yung design niya, that is 73.68 kilowatt. Okay? Pero pag gusto mong babaan yung frequency mo, okay? So, bababa yung flow niya, then bababa yung head. So yan, makakatipid ka pa rin, 46.86. So yun lang yung kanyang play dyan when you use the BFD. Paglalaruin mo lang dun sa flow and the head. Okay? Okay. So, of course, yung maintenance, very important. So ito yung mga photos ng mga condenser saka evaporator tubes. Kasi yung condenser tubes mo, yan yung front sa fouling. Dahil ito yung direct connect sa cooling tower mo. So environment mo kung madumi, so na-absorb ng mga condenser tube mo dun sa chillers. Okay? So yung right side na photo at the upper right, that is the evaporator tube before and after cleaning. Okay? Yung sa naman, lower right, that is the condenser tube before and after cleaning. Ano ba impact pag madumi yung tubes mo? Pag marumi yung tubes mo, parang sa electrical, mataas yung resistance mo dun sa tube. So yung heat mo ngayon, transfer mo is very poor na. Okay? Ang mangyayari dyan, pag chinek mo yung mga readings sa chiller mo, mataas ang condenser approach. Ibig sabihin nun, kasi yung example, yung evaporator mo, tubig yung dumadaan dyan eh. Tubig, okay? Tapos may heat transfer ka through freon. dahil mataas yung resistance mo sa tube, yung heat mo sa tubig hindi ma-absorb ng preon. Okay? So pinakamagandang evaporator approach mo, same with condenser approach, is zero ideal. Ibig sabihin wala kang resistance, wala kang dumi. So ang ganda ng heat transfer mo for that case. Okay? Okay, next. Correction of deficiencies. Okay, this photo is on the air handling units. So pinapakita lang dito yung mga deficiencies like yung duct, may mga leaks, yung mga coil mo hindi na maganda. Okay? So among others. So ito kailangan i-condition mo to so that you can optimize the operation of your air handling units. Pag medyo hindi na maganda yung coil mo, ang laki yung energy na nasayang diyan. Okay, so sa amin, meron kaming projected na ginagawa for the replacement. Pag hindi na talaga kayang linisan, so meron ng projected for replacement. Okay. So another correction of deficiencies is yung mga ducts, okay, above ceiling. Kung minsan kasi di natin nababantayan yung mga contractors, maraming mga galing, yung mga artistic, okay? Tingnan mo yung left photo, ang galing nilang gumawa ng art. So paliko-liko yung duct. So that is bad. Kasi whenever you have more change of direction, losses yan losses. May mga may mga air disturbances, okay? So yung right photo, yung nasa taas, yan yung mga plexi duct na connecting sa mga diffusers, okay? So hindi rin tama yan, yung nakabaluktot. Losses, again, that is a losses. So dapat makorek. Ang tamang mga details is yung drawing dyan sa baba. Okay? So anong impact dun sa mga duct pag mataas ang losses mo? Kasi ang kailangan i-maintain mo lang is there is a specific velocity. Dito sa graph na to, yung normal application mo would range na 1,500 to 2,500 feet per minute. Tapos yung left side mo, yan yung static pressure. May corresponding static pressure dyan. Okay? So very important yung mga duct orientation, duct connection. Yan pinapakita yung discharge duct dito sa yung right side na nasa baba. Di ba? After the blower, medyo mahaba yung duct mo bago may transition. That is the correct installation. Kasi kung maigsi yung take off mo, then may transition kaagad, meron may problema ka, magkakaroon ka ng losses ulit for that. Okay? Okay. So maintenance and correction of deficiencies. Okay. The left illustration is a cooling tower. So pinapakita rito na dapat you should maintain yung mga motor mo, even yung mga belt, dapat maganda yung condition ng mga belt. Otherwise, may slippage ka. So hindi na maganda yung heat rejection mo if that would happen. Even yung mga feelers, this should be clean. Okay? So if it is dirty or not properly maintained, there is a problem on the heat rejection. Hindi mo maitatapon yung heat ng building mo sa environment, sa labas. Okay. Yung naman, right photo below, that is the condenser pump strainers na marurumi. So you should maintain na dapat free from obstruction so that we have a good flow of the both condenser and the chilled water pump. Okay? Okay. So in summary, report tip number 1 is optimization. Okay? So dito pinapakita lang yung cycle of the air conditioning system of the building. Okay? Yung cycle number 1, that is yung space mo sa building where there are heat coming from yung mga lightings mo, from the customers, yung breathing nila, yung mga air infiltration, so that is heat. So ngayon, pupunta lang sa kanyan, sa air handling units to condition, then yung heat na yan, ita-transfer lang niya sa evaporator of the chiller, okay? then ita-transfer niya doon sa condenser mo, then to cooling tower. Okay? So the heat inside your building, tinapon mo through the cooling tower, through this process. Okay? So yung bad system na pinapakita ko is an example of yung heat generation mo doon sa building is hindi nakakalabas. Okay? May heat ka sa building sa cycle number 1, yan medyo parang na-traffic siya dito. Cycle 1, 2, 3. Hindi mo nilalabas doon sa heat, doon sa cooling tower. So that is a bad system. Pag meron kang ganyan, there is a problem along your yung cycle mo, along your system. So ang good one, dapat yung heat generation mo which is inside the building, matransfer mo lahat from 1, 2, 3, 4 to cooling tower to reject dun sa atmosphere. Okay? Okay. So tip number 2. Okay. Electrical configuration. Yung right side, that is a system wherein yung system mo is 34.5 kV, then nag-transformation ka into 460 volts. Okay, 34,500 to 460 volts. 460 volts to cater yung mga electric motors mo and other, mostly electric motors, elevators, escalators. Okay, for the power and lightings, magkakaroon ka ulit ng transformation. 460, kailangan mo ng dry type para ma-transform mo into 230 volts to cater naman yung lightings and other power requirement. Okay? So ang nangyayari dyan, meron kang distribution transformer at kailangan mo pa ng dry type transformers. Kung minsan, if you equate, example, 2,500 kVA yung distribution transformer mo. Pag tinotal mo yung dry type mo, 3,000 kVA. Mas malaki pa yung dry type capacity kaysa distribution. Why? Kasi nung yung sizing mo, walang available na size. So you go to the available size which is higher. Kaya kung minsan, pag tinotal mo yung yung dry type, mas malaki doon sa distribution transformer mo. Mismatch. So ang laki ng losses. Okay? So ang losses mo dyan is, yan yung graph na yan, yung graph of the losses. Yung eddy current hysteresis, that is core loss, that is constant. Okay? And yung copper loss mo is related to your load. Okay? So ang laki ng losses mo for this system. Okay, rule of the thumb, copper loss 0.8%, core loss that is 0.3%, total of 1.1, rule of the thumb. I-try nyo i-check sa mga literature, mukhang pumapasok sa yung 1.1 total, 1.1 total, 1.1% total losses. Okay. Yung right side na naman na system, okay, thank you for the late Jess Santos for fighting. He fought very much for this 400 volt system. Okay? So karamihan ng buildings natin ngayon 400 volt system na yung ginagamit. So you do not need another transformation. So bibili ka lang ng distribution transformer 34.5 to 400, then 400 to cater na yung mga motors mo, then 400 mag-align to ground ka to cater na yung mga lightings and power load mo. Okay? Okay. So tip number 3. Dapat may involved na tayo sa design stage pa lang. Okay? Para as an example, kung gusto mong magkaroon ng solar panel sa rooftop mo, so dapat you can now incorporate this on the design of your building. Okay? So, yun pala. Reminders lang. If you wanted to have a solar panel on your rooftop, huwag kayong magamit ng Franklin yung conventional na lighting arrestor natin, yung Franklin cage. Pag ginamit mo yon, wala ka nang paglalagyan ng solar. Kasi every 7 meters yata yon, may lighting rod ka. So, yun, be careful. when you have an option to use solar do sa rooftop. Okay. Yung right side presentation, pinakita ko lang that for SM, we have now 9.23 megawatts installation of solar panel. So when you equate it, that is 1.497 million fully charged cell phones. Okay. So yan yung mga kanya. Yung analogy niya for the conversion. Okay. So another good practices that we did is yung pag install ng mga vestibules inside sa mga entrances of the mall. Okay? To limit the air infiltration from going inside the mall. Kasi we have a pencil pushing calculation before para ma-condition mo yung pumapasok without vestibule. In order to condition yung air infiltration, you should install 100 TR of air handling units. So, ang laking kanyan, ang laking energy yon. So, very important itong vestibule. Pressurized vestibule to. So, there is a blower, okay, so that it can pressurize. Para pumasok yung air infiltration mo, kakaroon lang ng turbulent dun sa loob to build up yung to meeting yung para makontrol mo lang yung outside air for coming inside your mall. Okay? Kasi mahirap palamigin yung air infiltration dahil ang taas ng water content. Lalo nasa nasa tropical country. Okay? Okay. So another good practices is yung paggamit ng mga round duct. Okay? Round duct versus yung mga square duct. Round duct is more efficient because of yung less resistance. Okay? So yung paggamit ng mga low E glass for the exterior glass wall. Okay? And another tips, because when some of the malls or some of the buildings are now starting to shift using yung distribution transformer ng oil field to cast resin. Okay? So because yung oil field, they have a lot of experience on the oil leaks, especially on the bushings. Okay, so to get rid of that issue, so naiisip ng mga ibang designer to use na with the cast resin. Pero with the presentation dun sa right side, yung right upper mo, na pinapakita dito, yung 2,500 kVA, most efficient pa rin yung liquid field. Compare mo sa cast resin, dun sa vacuum pressure impregnated. Okay? Kasi mas mas maganda yung heat rejection mo because of the oil. There is an oil both insulating and for the cooling system. Okay? So for the lower illustration, that is a cast resin. So we're showing you kasi meron na kaming mga biniling cast resin. Okay? So dito lang, we would like to share you dun sa mga yung mga temperature rise and yung anong bibilhin mo na temperature rating. Okay? Because there are class F na 80K yung temperature rise, there are class F na 100K yung temperature rise. Okay? Ano ba yung mas efficient? Okay. So meaning yung temperature rise mo na 80 versus 100, mas mainit yung 100. Mas malamig yung 80. So less heat ka, less efficient, more efficient ka, okay? So very important na when you select a mga dry type, please make sure na i-consider mo yung mga temperature rise and temperature rating. Okay. Okay. So for this, with our energy efficiency programs and initiatives, we do not like self-service. So what we did is we have requested from our audit to audit our initiatives. So ito yung lumabas na during the audit, yung mall, yung SMBD, Bacolod yan. Yung CO, that is Cagayan de Oro. Yung BL, that is Baliwag. Yung RS, that is Rosales. Yung SR, Santa Rosa. Yung DM, Dasmariñas. Yung MK, that is Marikina. So dun sa right side, yung reduction in the mall's electric consumption, yung pinakita na nakakapag-reduce kami ng 20%, 26%, 35, 38. So, pwede talagang kanyan, ma-achieve yung ganyang kalaking cost avoidance. Okay? Okay, so these are the awards that we have gotten nung nauso pa yung Don Avelio, na sinabi ko kanina, nakasama ko si Chairman Perry. Okay? Okay, so yan, ito yung pinakamalaki namin noon, anong year to na marami kami nakuhang awards. Then we have saved more than 431 million. Okay? So, yung tip number 4 lang, kailangan ng management push and support. We would like to thank lang our management for pushing us to go with yung mga green or to do the energy efficiency program. Our president at that time, si Mr. Hansi, has gave us a marching orders to put energy efficiency as a top priority, and our improving performance shows that we are on the right track. So to translate, yung combined energy reduction that we have shared, yung 30.78 million liters of oil equivalent, that is 52.78 million of kilowatt hours reduction. So in terms of emission, so that is equivalent to 27.1 million kilograms. Okay. So that's all of my presentation. Thank you very much.
Okay. So thank you, Press Charles, for gracing us and sharing your practices sa SM. So as mentioned by Press Charles, matagal na kaming nakikita niyan sa pag-receive ng award. Kami mga antigo ng DOE, sabi nga. Anyway, thank you again. Kasi ang Metro South ngayon, merong kasabay na energy program. So nag-grace pa rin si Press Charles ng kanyang time para i-share sa atin ang kanyang mga energy practices as an energy practitioner. Okay? So, we'll now go on sa question and answer. So, from Hildon Budtan. So, how about calibration of kilowatt-hour meters? So, maybe he's asking practices on this one.
Yeah, what is the name of
Hildon Budtan.
Yeah, you're Hildon. Yeah, that's a good question. With yung DSOR natin, yung Distribution Services and Open Access Rule, kasama sa rule yon na you can request sa DU for the calibration of your energy meters. Tama ka. Kasi minsan nagduda kami sa metering namin because the DU meter, when you compare it with our installed meters, malaki yung diferensya, mga 5%. So, million pinag-usapan. So, that would be a great impact. So, what we did, we have requested Meralco for the calibration. So, yun. Napakita naman na tama yung metro nila. So, mali yung metro namin. Saka, number 2, yung ginagamit kasi ni Meralco na metro is 0.2% yan. Tapos, yung city niya, very efficient. 15% yata. Even yung potential transformer, very efficient yung gamit niya. So, for us, baka hindi natin kayang bilhin yun eh. So, there would be a discrepancy talaga. So, mahal yung kasi ayaw niyang malugi. That's the reason why they are using yung mga most efficient na PTCT. Okay, so I hope I answered your question.
Okay. So thank you for that. Another question from UNIDO expert, a national expert, Engineer Del Manalo. In using dry type transformer over oil-filled transformer, how do you overcome space requirement considering in malls or in commercial buildings, area is very expensive?
Yan, Engineer Manalo, nice question. Okay. Ang cast resin compared to oil field, mas malaki yung cast resin. Yung 2.5 mo, nako, parang giant pag kinompare mo eh. So kasi for the mall, yung binibigay ng architect sa amin na area for the substation is yung hindi na nagagamit for the tenant spaces, which is nasa deck kami lagi. So kahit malaki yung hingin namin, there's no problem because hindi na rent out. Problema lang doon kung malaki yung bibilhin mo, yung structural lang. So pero yun, mas malaki yung sizes of cast resin, number one. Number two, mas mainit siya. So please consider yung ventilation. For the abroad, usually lahat ata naka-aircon yan eh, yung cast resin. So for yun, consider lang yung proper ventilation when you go to cast resin. Mas mainit talaga compared sa oil field. Okay, thank you.
Okay, thank you, Press Charles. So there's no other question na nasa Q&A natin. So I guess I can turn over the floor to the presentation of the certificate.
Chairman?
Yes, Vice Chair.
Dala na lang sa akin yung kung sino yung bibigyan natin ng 1K.
Yeah, tinext ko na sa iyo yung bibigyan natin.
Okay, thank you.
Good afternoon to all. Institute of Integrated Electrical Engineers of the Philippines, Incorporated, Energy Efficiency and Conservation Committee presents this certificate of appreciation to Engineer Charles Singson for imparting valuable insights as resource speaker on the topic Best Energy Practice Shopping Mall, giving this 12th day of December 2020, Philippines. Signed by Christopher Villaflor, Chairman of the Energy Efficiency and Conservation Committee, and Rodrigo T. Picalera, 2020 IIEE National President.
Thank you, thank you. Thank you, Chairman.
Thank you, Vice Chair.
Okay, once again, thank you very much, Sir Charles, for sharing to us those informations regarding that topic, best practices on shopping malls. So before we proceed with our next technical presentation, can have our short breaks po muna. Pwede po tayong mag-CR and mag-coffee, and then we will be back after 15 minutes. Tama, sir? Yes, 10 to 15 minutes. We will proceed with the next presentation. Okay, good afternoon once again to everyone. And before we proceed with our last speaker for this afternoon, we would like to announce again that we will be having a raffle after this event. And this is sponsored once again by the Virtual 3E Expo 2020. So we will be giving away three pieces of the IIEE notebook with pouch, three pieces gray IIEE polo shirt, and the grand prize will be the mountain bike. So also after this one is we will also have a performance from Miss Lana Roy. So now for our last topic this afternoon. Our speaker graduated with a BS Electrical Engineering degree from the Mapua Institute of Technology in November 1992. He earned the degree in 4.5 years instead of the regular 5-year course length and graduated in the upper 5% of the class. He was a member of the MIT team which won the IIEE NCR quiz show in 1992. He took the Electrical Engineering Board examination in April 1993 and was the 8th placer among the successful examinees. He have also completed MBA units for postgraduate course, finished the Facility Managers Development Program at Arizona State University in year 2009, and completed the Management Development Program Certificate for Hospital Operations at Asian Institute of Management in year 2018. and recently he graduated from Singapore Management University on Hospital Management Program. So he is the Vice President and the Head of Facilities Management and Engineering of St. Luke's Medical Center in Quezon City from June 2018 up to the present. So let us all now welcome Engineer Noel Pabelona.
Thank you and good afternoon. Thank
Good
you for your
afternoon, sir.
invitation. Yeah. Thank you, Chairman. Good afternoon. Good afternoon to all attendees of this seminar. So I'll be sharing my screen. I'll be talking in Tagalog as well para mas maganda yung ating discussion with the permission. Mhm. Okay. Let me know if you can see the screen now.
Yes, we can.
Okay. Thank you, Chairman. Good afternoon again. So I'll be providing you an insight of the techniques and how a successful energy efficiency programs is being implemented. Okay. Uh, so this is the sequence. We'll start with the framework, the aspects of energy management, Pareto and prioritization. Probably most of you heard about how Pareto works. Right? Implementation, monitoring, other projects being done, and the continuous improvement. Okay? So to begin with, we need to start with a framework. Okay? So, of course, what is the purpose? Some would say we are compelled by necessity, financially. So, merong pressure coming from upper management. We need to save because tama nga naman, if you are in manufacturing, lahat ng products natin ngayon, if you manufacture it now, it won't sell the same amount tomorrow. So you need to do something else so that your cost of operation will be lower versus yesterday. So yun yung dyan. Yun yung always na discussion. No? And required by regulations. Of course, we have this RA now, RA 11285, no? And will take effect by next year, full effect na siya. Required by industry, certifying body. So sa hospital is JCI and some other companies. If you're in manufacturing, you're going to ISO 14001, OSHAS, etc. No? Yun yung mga requirements. Because some of the manufacturers going to tie you up. No? Hindi sila bibili sa'yo unless you are already certified. No? And of course, corporate social responsibility. May kasama na ditong feel good to sa company, feel good sa atin. And of course, we feel good because we can participate in the preservation of our resources. No? When we do this, lahat kasama. No? So yun yung mga main reasons of why we do this. Okay? So we go now doon sa framework. How do we do this? No, yun yung next na question. No? To have a very successful program, you need to have the support of the top management. Well, the pyramid is a very effective, I should say, representation of how it works. People at the top, nandoon sa ibabaw ng pyramid, are the top management. So we need to have a policy, yung SOP, strategy. Because without the support coming from the top management, regardless of how good your project is going to be, hindi siya masusuportahan. No? And to be able to have this project, sabi nga nila, di ba, you need to document what you do and you do what you document. Yun yung primary doon sa ISO. And meron dapat tayong policy to start with. No, kasama dapat sa policy natin that we are we need to support yung resource reduction so that magkaroon tayo ng projects on energy efficiency. Of course, yung SOP susunod doon, ang mother policy mo, then SOP, then yung strategy. Kailangan nakalink siya sa strategy ng company. Okay? And sa middle niyan, you have the energy manager. Ito na yung taong magpa-plan, mag-establish, and enable to do the things that we have planned to do, no? Si energy manager. So malaking uh, role niya because he is the link between the top management and doon sa gagawa talaga. So kaya yung sa bottom ng pyramid, mas malaki siya kasi nandoon yung base natin, yung ating mga tao, yung ating teams, no, that are going to be supportive of what we are going to plan or to do, no. And why cross-functional teams? Because malimit sa mga activities kung hindi yan kasama yung ibang members. Example, no, facilities lang yung gagawa, hindi kasama si EHS, hindi kasama yung finance na mag-check nung gagawin mo, hindi kasama yung taga manufacturing or taga hospital operations. Yung support niyan is magwa-wane, no? Sa umpisa lang meron, pero pagdating sa dulo, dahil sila dapat yung nag-own, no, merong accountability, hindi siya magsa-succeed, no? And to make this work continuously, you have the management review at year's end, no? So ito yung structure that ano rin to sa Deming cycle of PDCA, Plan, Do, Check, Act, no? Kasama yan dyan. Management review is the best way to go about, nagawa ba natin yung sinet natin? Have we accomplished it? And if hindi, ano yung dapat nating gawin to be able to improve on? And also, we are going to review, baka merong mga bagong regulations or requirements coming from customers na kailangan nating i-enhance yung ating mga programs. Of course, the top management will say, okay, approve, disapprove yung ating mga proposals. No? So we go now to the aspects of energy management. No? I have listed 12. Karamihan naman dito is alam kong ginagawa na rin ninyo. No? Just a reminder that policy management support. No? Second, yung benchmark. So why do we need to do benchmarking? This is to ensure that, kumbaga, are we at par? Are we below? Or if we are best versus the benchmark, we need to increase that gap. And probably, kung nasa industry kayo, they share that knowledge. No? Yun yung purpose nun. Of course, establishment of teams, then you go measurement. No? Goal setting is next. Because after measurement, you know now ano yung gaps and ano yung realistically can be achieved doon sa mga gagawin natin. Then afterwards, we plan, of course, the execution, yung monitoring and control. This one, malimit dito nagkakaroon ng pushback, no? Especially kung yung projects is hindi ganun ka-successful, no? Yung iba nahihiyang mag-report. Yung iba tinatakpan yung report. Under-reporting, over-reporting are bad, no? So, kaya gusto kong i-highlight na in this list, no, important yung monitor and control, no, for a project to become successful. No? Yan, management review, then continuous improvement. And if you are working on multiple sites, of course, you need to pan out. No? Hindi po pwedeng ikaw lang yung nagsasucceed. You need to share your ideas. Yung mantra for energy management for so long a time, what you cannot measure, you cannot control. Di ba? Kaya dito, may nagtanong about meters kanina. Yes, very important ang meters. Kasi hindi ka makakapag-start ng measurement kung wala kang metro. So, if you are planning to do energy conservation, you need to do your measurement first and make sure that nakukuha mo lahat yung load. Baka kasi yung loads ninyo na kino-consider hindi pa pala kumpleto. So, hindi magiging accurate yung iyong gagawin. Kasi parang losses yan nakuha ko na to pero bakit hindi pa rin bumababa? Kasi hindi mo nakuha yung ibang load. Okay, we go now dun sa I'll share you yung parang typical na sa isang hospital, how is loads measured, no? Ano yung percent ng load? I cannot tell you ano yung eksaktong demand in terms of kilowatt, but I can tell you ilan yung in terms of percent, no, because of confidentiality of information. Typically aircon. I think kahit sa industry yata, aircon yung talagang mataas. Probably because we are tropical country and we need to have, like for example, in a hospital setup, karamihan talaga air conditioned yung area, no, almost 100%, because you need to make sure that the patients are taken care of. Of course, yung sa mga machines na ginagamit natin needs to be in a practically cold environment, no. OR nga, ang requirement pa ng mga doctors yan dahil naka-pull gown sila at yung iba naka-lead vest pa kung meron silang gagawing mga special operations, no. 18 degrees centigrade, yun ang requirement nila para dun sa temperature, no? And yung ANS dyan, it connotes for ancillary, no. Ito na yung mga pathology, ito na yung mga imaging natin, yung ating X-ray, CT scan, PET CT, MRI equipment, no, nuclear medicine, etc. No? Yun yung sumunod. Kumbaga sa manufacturing, ito yung manufacturing equipment eh. No? May relationship din or merong analogy, no? Then yung air plant, vacuum, compressed air, compressed dry air para sa ating support sa medical gas, no. Then yung mga patient rooms that includes the lighting sa natin and other auxiliaries 10 and 5, no. Yun yung typical demand sa isang hospital or healthcare facility. And one of the biggest project that was undertaken is to convert, no, yung mga window type, no. Yung isang hospital kasi is circa 1950s, 60s ginawa. So typically, of course, yung mga air conditioning yan is hindi centralized, working on window type units, no. And alam natin typically hindi siya efficient, no. Ito yung kanyang kilowatt per ton, is about 0.9 kilowatt per ton, no. Yun yung typical measurement niya. And we change going to centralized air conditioning, no. A big portion of the hospital is now under central aircon. And if you calculate yung total kilowatt hour per ton, chiller will account about mga 0.6 kilowatt per ton. Yun ang chiller, ano. And ang ating mga pumps would account for about 0.11, gano'n, ano. Cooling tower is about 0.06, more or less, no? So, lalabas natin total dyan, mga 0.78. So, may diferensya, no? Kasi yung iba, kinakalculate lang using yung chiller. Mali. Kasi yung chiller, normally, kung maka-efficient na ngayon, nasa 0.55 eh. Meron pang nagkiklaim na sub 0.5. 0.45, 0.48 nagkiklaim sila. But if you want to compare the entire system, you need to include yung ating pumps, you need to include yung ating cooling towers dun sa calculation ng ating air conditioning. Of course, yan yung then the HU. Ayun yung may savings of about more or less 1,700,000 kilowatt hours per year, no? So from window type going to centralized, at yung total niya dati, demand, at yung savings siya on peak demand. Of course, we had this demand factor of 0.7 so operations ng hospital, no? We have the hours in a year. Energy save is about this much, no? Hindi ko na nilagay yung rate. You can calculate naman based doon sa ano yung na-receive yung rate sa industry or sa company nyo, because we are bound to preserve yung integrity ng bid ng ating mga RES, no, retail energy supplier. We don't want to divulge yung information about rates. Okay, so question nga about this one, ito ba ginawa namin or is it done outside? So two things that we can do this one, no? Internal investment or through energy savings company. And we have done this through ESCO, no? Long-term cooperation with a contractor. So how it was done, of course, we had this baseline goal setting. We created terms of reference. Then we have pre-qualified yung mga contractors. Then doon sa pre-bid conference, we told them ito yung aming requirements, ito yung terms, ito yung et cetera, no? And of course, you need to set after the cooperation period kanino yung makina, no? Kasama yon. Then there goes the bid evaluation. Bonds, insurances, and afterwards is implementation, testing, and commissioning, no? Ngayon, siguro may question, ilang taon, no? Typically, pagka ganitong investment, you go about more than 20 years, no? Yun yung typical na, at least dun sa mga na-receive namin, no? Of course, it will be dependent on how intensive is the air conditioning to the demand of the entire facility and the rate that you are getting, because kasama sa factors yun eh, no? And monitoring, because we need to ensure that all the contracts, sections or inclusions, exclusions are really being done, no? Ito, just want to share with you, no? Of course, kilowatt to. Ito yung for the year. Yung baseline, of course, wag nating kalilimutan na pagka nag-start na yung cooperation period, meron kang load na madadagdag, ano? Meron kang kukuning year na ito yung pag-agreehan nyo na ito yung baseline ko. Then, from that baseline, kung may additional load, you and the energy savings contractor need to agree na okay, add yan, sasama yan dito sa baseline natin, and we need to see kung talagang bababa pa rin yan kahit mataas yung demand na dahil doon sa additional load, no? So ito yung projected load, ito yung actual. So even to dun sa projected, mas mababa pa rin yung actual. And the total savings that we got from here, ano, is about 14% actual savings. So yun yung major, no? Now, nawala yung pareto natin. Sa ancillary, no? Ito yung mga technology leap, no, from that's why we were able to save, no. Depende na kasi dun sa mga model ng equipment. We have several, no, but the main reasons, no, kung bakit we were able to have less film to digital, no. Wala ka ng pag-film processing ngayon, at saka yung equipment mas efficient, mas maliliit na siya, no? Actually, merong mga X-rays ngayon na you can transfer from one room to another na, no? Ganun ka-liit and napaka-efficient. And yung mga CT scans natin, no, meron tayong unang-unang CT scan, 2 slice lang. So you imagine yung isang portion ng yung katawan, no? Dati kalahati lang yung pwede mong silipin doon pagka nag-CT scan ka, no? Yung computed tomography nating tinatawag na system, ngayon more than 1,000 slice na. So, ganun kataas na yung resolutions, ganun kaganda. Same time, saan ang savings doon? Savings natin doon sa equipment itself and diagnostic, better health management doon sa ating mga pasyente, no? Ngayon, sa pangatlo natin, no, remember, balikan natin yung we have sa Pareto natin, no? Sabi natin diyan, pagka ma-capture mo yung 20% ng iyong problema, 80% yung balik sa iyo. So we have discussed yung aircon, yung sa ancillary, and air plant. No? So tayo sa air plant ngayon. Ayan. So malimit, no? Yung CDA or air compressor system natin na taken for granted. Bakit? Kasi yung mga empleyado sinasabi, it's just hangin lang yan di ba? So may marinig silang leak, they don't mind. May makita silang problema doon sa equipment nila na hindi na maganda yung pneumatic system niya, tataasan lang ng pressure yung kanyang bubukas pa ng valve, so wastage. No? Kasi sabi nila, it's just air. Libre. Pero hindi, no? Of course, everyone sa industry, alam natin na pag kami leak, correct lang yan. And normally, yung rule of thumb natin dyan, di ba? It's 1 PSIG na masave mo is almost 1% na ng energy consumption yun, ma-take mo as savings, no? So, isa pang problema sa CDA system is about yung design constraints, no? Yung open-ended pipeline sa mga luma, ito, typically, maraming lumang system, nagtitipid, no? Hindi na kin-closed loop yung system. Ano yung better way of checking kung effective to, no? Based on experience, kung yung isang open-ended pipeline from the source going to the last point of use, kung meron kang pressure gauge doon, it can go down as high as more than 10 PSI, no? Based on my experience. But kung may closed loop system ka, we have checked this doon sa ibang mga sites namin prior to meron kaming mga multiple sites doon sa manufacturing sa Malaysia, Vietnam, sa China, no? Kung naka-closed loop yung system, as efficient as about 2 PSI lang yung drop, no? Ganun kababa yung pressure drop, which means you can better handle yung demand. Pwede ka pang maglagay ng mas maraming equipment at the same time with the same equipment, no? Tataas yung efficiency yung utilization ng makina mo. Maganda yung pressure regulation. Yan, pipeline not properly sized up, low pressure at end of the line. Yun. And air receiver not properly sized up. Sabi nga nila, no, if you have this properly sized up, parang meron ka ng isang free air compressor doon sa line mo kung merong maganda yung air receiver mo. Because it absorb any surges doon sa demand ng linya. Instead of switching on ang isang compressor pa kung naka-automated yung system nyo, which yun ang mas magandang setup, no? Nagko-call lang siya ng meron kang lead na compressor, then the rest would be called upon kung kailangan pa. Hindi mo na siya magtatawag to run another compressor, but doon mo na siya kukuha sa air receiver. Efficiency. Yan. Alam natin na inefficient yung mga air compressors. Mostly 15 to 20% lang yung efficiency niyan. No? And yung second bullet dito sa slide, yung 4 CFM per HP compared to typical HU fan or about. So meron kasing mga application, no? Ang ginagamit nilang pang dry is CDA. Pwede namang hangin lang yan coming from a fan no? HU or what, no? O exhaust, etc. So ang laki ng diferensya. Makakasave ka ng malaki diyan. Isang typical application nito doon sa drying sa plating shop, no? So, yung pang-dry nila ng mga ICs doon sa plating machine, dati ang gamit is mga compressed air, no? So, pinalitan namin yun ng mga blowers, no? Ang laki ng savings doon sa area nila. Kitang-kita doon sa demand meter na nilagay doon. Of course, when you go reciprocating compressors, etong isa is yung 5.5 is mga screw, no? Hindi ko na ilagay dito. Tama. Reciprocating compressors offer 4 to 5 CFM per horsepower, while yung mga screw compressors is about 5.5 or to 6.5 CFM, no? About 30% more efficient. And dryers, no? Do not overdo the use of dryers, no? Kung hindi naman kailangan ng mababang pressure dew point, doon ka sa refrigerated dryer that pwedeng mag-output ng 0 hanggang 5 degrees, no? Kasi iba, hindi naman requirement yung mababang pressure dew point, naglalagay pa ng desiccant type o molecular sieve type na dryer, no? So kung doon na lang sa mga point of use, doon ka maglagay. Isang typical nito, isang factory namin, which is nilagyan lang namin siya ng ng molecular refrigerated dryer doon sa main. Then dalawang areas lang naman yung may kailangan ng mas mababang pressure dew point of -40. So yun lang nilagyan ng ng desiccant type. So meron tayong savings dahil wala kang purge din doon. Ito yung calculation lang, no, kung bakit mababa yung efficiency natin. Okay, so ito yung it's taken from plant services, no. Typical setup ng isang CDA system, I think na efficient, no. So you have the air compressor, no. Meron kang heat recovery na gawa na namin to, no, dati. The heat recovery, the heat recovered from the air compressor, nilagay namin doon sa heating system para sa plating shop. So doon namin dinala yung so meron lang heat exchanger siya. Then meron kang dryer, no, of course the filter and the air receiver. Then, yung pipeline natin is a closed loop one, no? So, may mga questions about example, doon sa mga merong mga process talaga na kailangan nilang magbuga ng hangin para release ng mga piyesa sa machine to take them out. So, lagyan mo siya ng port pero meron dapat regulator na hanggang 20 PSI lang yung gun niya, no? Merong ganong nabibili na, 20 PSI na pressure gun. And ang isang savings na makukuha pa natin dito is about doon sa type ng dryer din. Kung molecular sieve ang ginagamit nyo or yung desiccant type, meron pa diyang purgeless dryer, no? Kasi normal na lumabas dati, which is mas mura, is yung mga purge dryers. So ginagamit niya rin yung hangin na in-output mo na para ibuga lang doon sa desiccant para ma-regenerate yung desiccant. Yan. So, okay. So, ano yung mga other projects, no, that currently being done as a continuous improvement? Is LED lighting, no? When we started, siguro yung cost ng isang LED light is about 4,000 pesos per lamp. Ngayon, less than 1,000. So, mas madaling mag-implement ng project na to versus previously. Kung dating meron kang mga payback period na less na mga 5 years, ngayon, mabilis na ang payback niyan. No? BFDs. Well, yung previous si Engineer Charles, sinabi niya is about, ganda yung presentation niya about the BFDs, no? Yes, malaking tulong sa mga pumps, AHUs, sa exhaust system yung BFDs. Isang downside lang nito is yung ating harmonics, no? Kung may mga sensitive equipment kayo sa tabi ng mga machines that you have supplied yung BFDs, better to have meron ka ng mga filters, no? O meron namang nabibiling BFDs na may filters na ngayon eh. Ito yung heated purgeless dryers. Okay, isang project, very tricky to, yung cooling tower fan blade retooling. So papalitan mo yung aluminum mo na blade to fiberglass. So may mga successful netong project na to, and meron ding hindi. You have to consider yung efficiency nung cooling tower after replacement. So bago kayo mag-go for a total replacement, make sure na pag-aralan nyo maigi. Kasi kung hindi magiging efficient yung inyong cooling tower, lalabas yan na magkakaroon kayo ng high approach doon sa condenser pagka hindi na siya efficient at magsa-surge yung unit nyo. Typically. Installation of motion occupancy sensors, no? Especially doon sa pagka demand based yung isang area, like doon sa mga ancillary areas, no? Maghihintay na tao, konti lang tao, so you can put in occupancy or motion sensors. Room temperature rationalization and air distribution balancing. So maraming kaso na malamig dito, mainit doon. So ang suggestion ko is you take a snapshot nung lahat ng areas ninyo, then tingnan nyo kung anong areas yung within lang doon sa requirement and ano yung sumusobra naman sa lamig. Dali nyo siya doon sa requirement. No? Sometimes yung very simple things of doing measurement talaga would take you a long way. Yung power factor ng ating distribution system, dati malaki ang discount nito sa Meralco. Of course, yung iba, wala. But in terms of operations sa atin, mas maganda kung na-check pa rin ito. No? Dahil yung capacity niya is, of course, may increase yung ating capacity if we go with a higher power factor system. Ito ginawa din, automated yung water treatment sa chillers, sa ating cooling towers. So, minsan ito yung natitake for granted yung ating water treatment. So, ang typical na rule of thumb is that you need to keep yung inyong condenser approach sa chiller to below 5 degrees Fahrenheit. No? Sabi nga ni Engineer Charles kanina, ang pinaka-ideal is 0, pero hindi nangyayari naman yon. Dahil siguro sa startup mo, bago yung chiller mo, pwede. Pero as you go along, may kakaroon siyempre ng scaling na yung loob niyan kahit na nililinis mo siya. 0.1, 0.1, ganon ang magiging typical na approach ng ating chiller. And if you go 2.5, okay pa rin yan. Pero pagka lumagpas ka ng 5, problema na yon. Ito, no? Yung UPS replacement, yung mga dating very old UPS, yung mga transformers niya, matataas ang core losses no? Malalaki. Inefficient na UPS. At the same time, standardization ng mga voltahe. No? Conversion ng primary metering ng mga present pa na secondary metering para ma-achieve yung RES savings. Excuse me, ma-maximize yung RES, no? And ito is water to, sinama ko na rin yung water recycling, no, sa STP para sa flushing. Pwede rin yung gawin sa plant watering, but you need to consult yung inyong EHS dahil may mga requirements yan before you do para sa plant watering. Ayun lang po. And yun lang yung pwede kong i-share for the meantime ngayon sa energy efficiency. Thank you.
Okay. Thank you very much, Engineer Noel Pabelona. So, incidentally, si Engineer Noel Pabelona rin ang interim chairman ng Committee on, PEC 3, maintenance ng IIEE. So, at meron din trend. Did you know that Engineer Alan Alvarez, the incoming president, national president, Engineer Noel, and ako magkakaklase sa college. So, Kaya kami nandito siguro sa IIEE dahil kay Alan.
Yes.
So anyway, we go on to the question and answer. So meron tayong isang question, I guess. I don't know if medyo related, di yata related. Pero I will read the question as well from Hildon Budtan. Kanina nag-question din siya. Sir, pag nag-brown out, makaya ba ng standby generator ang buong load ng building nyo?
Yes, sa hospital dapat, no? Of course, meron pa tayong redundancy diyan sa generators natin. So, typically dapat pumasok yung ating system within 10 seconds, dapat naka-light up na lahat tayo. Yun ating rule of thumb sa hospital. And yes, dapat buong load ng building kasama.
Okay. So, any other questions na pahabol? Wala na yata. So with that, we'll be turning over to Secretariat Brian for the presentation of the certificate.
Hello, good afternoon. The IIEE Institute of Integrated Electrical Engineers of the Philippines, Incorporated, Energy Efficiency and Conservation Committee presents the Certificate of Appreciation to Engineer Noel Pabelona for imparting valuable insights as resource speaker on the topic Best Energy Practice Hospital Facilities, given this 12th day of December 2020, Philippines. Signed by Christopher Villaflor, Chairman of the Energy Efficiency and Conservation Committee, and Rodrigo T. Picolera, the 2020 IIEE National President.
Thank you, Chairman.
Okay, thank you again, Engineer Noel, for sharing your best practices.
Okay, now before we proceed with the EECC report, our very own committee chairman, Engineer Christopher Villaflor, will be presenting also another best energy practice, which is yes. So the topic that the Chairman Villaflor will be presenting is about electronic manufacturing. So before we proceed, I will read to you the short profile of our chairman. He is a professional electrical engineer and an ASEAN chartered professional engineer with specialties in facilities planning and operation management and energy management. He is a certified ASEAN energy manager, a certified PADI scuba diving instructor, a certified international emergency first response instructor, Six Sigma Black Belt, a graduate at Mapua Institute of Technology with BSEE, the president of Texafil Inc., Facilities Engineering Operation and Planning Consultant, an ETAP Power System Analysis Professional, the former Facilities Energy Manager of Toshiba for 18 years. And he is a 3-time DOE Outstanding Energy Manager Awardee, an ASEAN 2011 Best Energy Management Practice Awardee, ASEAN Best Special Project Awardee for Heat Recovery System, and a DOE Secretary Awardee. He is the 2019 IIEE CLC President and our 2020 IIEE National Chairman for this Energy Efficiency and Conservation Committee. So let us all welcome again our Chairman, Engineer Christopher Villaflor. Sir, black belter ka pala, sir.
Oo, black belt.
Scuba diver pa, sir.
Oo. Marami tayong racket, kala nyo. So,
Sporty.
Anyway, actually bonus presentation to since we still have time. Sayang naman kung magpo-post tayo before the presentation of Lana Roy. So, can you see the presentation?
Yes, sir. Yes, sir.
Yes,
Meron.
sir.
Okay. So, okay. So, I will be sharing you yung mga best practices naman na na-install ko before sa electronics manufacturing industry. So, as mentioned, I was involved with Toshiba Information Philippines for almost more than 18 years as a facility manager and facility energy manager. So, yan. So, we start up with the energy efficiency approach. So, ang ginawa kong approach nun for energy efficiency is first, we focus on design optimization. Then, we have redesigned the chiller system. Redesign talaga namin siya totally. So, we go into the renewable energy or the heat recovery system and efficiency maintenance, particularly on chiller operation. So, start with the design optimization sa chilled water systems namin. So, this is the power share ng company namin before. So, imagine, we are operating at 17 million megawatt total demand. So, we are operating with a generator a power plant, a diesel power plant, and for 57%, and Meralco, we are getting power 43%. So here we have gensets of 24 megawatt capacity and 18 MVA capacity of Meralco. So, sorry. So, okay. Wait lang ha. Okay. So, ito yung energy drill down. So, a while ago, ini-stress nila, 'di ba, yung Pareto, even Engineer Noel. So, Pareto is very important to know what to attack, 'di ba? Sa dating sa seminar ko nga sa energy management, I'm always saying, wag niyo nang atakihin yung ilaw, maliit lang 'yon. Unahin niyo yung malaki. So, with this, you can see that our chiller is contributing 23% of the energy consumption. So, we go on with the low efficiency factor. So, the company was established 1996. So, talagang matatanda na yung mga equipment namin. So, before, we are using air-cooled chillers sa factory namin. Nung in-evaluate namin yung aming performance and significant factors resulting to high energy use is yung first, nakita namin yung system design namin. Pinag-aralan namin, system design namin, what is the best design para ma-improve namin ang energy efficiency. Next is equipment, particularly the chiller and the pumps. And of course, the control system, particularly on the pumps. So, ito yung itsura ng planta namin. So, because of continuous expansion ng planta, so we started up, meron kaming isang set for chiller, ng chiller namin. Then, nag-expand kami again. So, nagkaroon na naman ng another set of air-cooled chillers. Then again, another set and another set. Nagkaroon kami ng bagong building. So, another set of chillers. So, our total capacity of cooling system is 5,400 tons of refrigeration. However, nung in-evaluate namin, ang demand namin is 4,800 tons of refrigeration. So, ito yung mahalaga pag kayo nag-consider ng upgrading or improvement ng energy efficiency, to know really what is your actual demand. Kasi usually sa air conditioning system, over-designed. Hindi lang over-design, yung over-design pa, ino-operate. So, over-operated din. So, what we end up is to convert the total design to a centralized design. So, kanina, nakita nyo, Chiller 1, nagsusupply lang siya sa production A, Chiller 2, nagsusupply sa production B, Chiller 3 sa production C. So, here, you can see yung running capacity, the required capacity, and the excess capacity ng bawat system. So with this, a total of 1,348 tons of refrigeration is being wasted kasi tumatakbo siya kahit di mo kailangan. So around 1,752 kilowatt of wasted energy. So what we did before is to make it centralized. We interconnect all the piping system for all the production areas. We converted or we installed turbo chillers. The screw type, the one mentioned by Engineer Noel, because the old chillers, the air-cooled chillers are all reciprocating chillers. And we have disconnected the low efficiency chillers, yung matatanda na, particularly the chiller 1, chiller 2, and chiller 3 na nagko-cost na ng high energy. So on design benefits, so we minimize cooling loss due to renewed piping system. We eliminated unnecessary operation of standby capacity. Kasi before, kailangan mo marami kang standby. Yun yung main reason. Kasi dahil nga we are into production, manufacturing business, kailangan may redundancy ka rin. So if you have many systems and many redundancies, mas maraming nasasayang. Unlike pag nag-centralize ka, yung redundancy mo, magko-custom fit mo lang dun sa system ng centralized, yung sa system na nasa centralized piping mo. And of course, we eliminate low efficiency chillers and pumps, yung mga luma. So, yan. As mentioned, we have converted. So, yung air-cooled chiller, so bilang energy practitioners, it is very important na alamin nyo yung performance, yung energy performance ng equipment na naka-install sa inyo at yung mga energy performance ng mga available sa market. Kasi lahat halos natatakot sa investment. So, if you know the energy performance, kayang-kaya nyong may justify, especially for the top management, kung ano yung mas in the long run. Actually, ngayon, very short time na lang, hindi na long run, na mababawi mo, mababreak even mo yung investment mo. So here, so air-cooled, ang energy performance niya is 1.3 kilowatt per TR. Now, when we have studied possible replacement, we ended up, we call it a turbo chiller, at 0.8 kilowatt per TR. So you can really see the difference. Dito pa lang kitang-kita nyo na yung difference sa energy performance pa lang. Now, when we installed sa old design namin, so we have a total of 6,400 kilowatts sa old design namin. With the new design na hindi na namin tinanggal na namin yung chiller 1, 2, and 3, and we have installed a total of 1,800 TR sa aming na tatlong 1,000 TR na turbo chiller. So we still use some air-cooled chillers. This one for base load para continuous na siya. So on the basis of our demand of 4,800 TR, so nag-reduce kami ng 35% in terms of power. So imagine, so only it's investment intensive, but 35% power reduction is a big deal if you are talking of the big contributor on the power consumption or energy consumption rather. Okay? So sa pump control naman, ito, di ba, talagang from from Engineer Manalo, Engineer Singson, and Engineer Pabilona. So talaga naman proven yung cube relationship ng BFD sa RPM. So with the old design, we have a flow rate of 46,321. We are using 23 pumps during those time. But with the new design, because when we installed the turbo chillers, so nag-install na rin kami ng mga bagong chilled water sa main piping, chilled water pump sa main piping with inverter. So hindi na namin pinalitan yung nilagyan ng inverter, yung chiller 4 and chiller 5, since they will run in base load. So remember, ito yung tatandaan nyo palagi, if the pump, hindi lahat ng pump and fans kailangan lagyan ng BFD. If your pump and fans is running at 100%, you don't need BFDs. So yun lang na tumatakbo na variable. So going back sa new design namin, ang flow rate na kailangan lang namin sa bagong system namin, centralized system, is 43,939 liters per minute. So we are now just utilizing 9 pumps. And the required flow rate only actually is 40,000 liters per minute. So dahil meron kaming inverter na install na namin ng BFD, so pwede na namin ibaba. So in terms of kilowatt, old design 629, again 23 pumps. New design only 435 kilowatt. So this one at 61% new pump control. So ibig sabihin 61% lang yung output na kailangan namin for the new pumps na nilagyan namin ng BFD. So this one resulted to 30% power reduction. So kanina nagkaroon na tayong 35% sa chiller pa lang, plus another 30% sa power reduction. So napakalaking benefit nun and very significant talaga sa aming operation. So some key points sa design optimization. So evaluate the total system design. Palaging evaluate nyo. Kanina binanggit ni Engineer Pabilona, kailangan checkin nyo yung design. Centralized setup, minimize flow loss, heat loss, and standby loss. So alternative equipment, use it. In our case, we use turbo chiller instead of air-cooled chillers, and optimize the control using frequency inverters and automated control system. Okay? So another approach is renewable energy. So before, during my time in Toshiba, hindi pa ganun kahit ang solar because it's very expensive. During my time, ang break-even ng solar is around 10 years above. May 15 years pa nga na nag-present sa amin. And net metering, hindi pa approve yung Renewable Energy Act. So kaya medyo lugi ang company pag in-applyan mo. However, there is a thing called heat recovery system. Meron din mga application na pinakita si Engineer Pabilona kanina, heat recovery system. Now, this is what we did. So, as mentioned earlier, meron kaming diesel engine power plant. So, we again started with the study. So, when we studied, actually, this is in literature also, and for mechanical engineers, alam nila ito. Ito yung heat balance ng diesel engine. So, for the 100% input natin, ang lumalabas lang for useful work ng diesel engine is 34% lang. So, saan napupunta yung iba? Cooling. So, ito yung kung sa sasakyan natin, ito yung sa radiator natin. Exhaust loss. Ito yung init na binubuga ng tambucho, 26%. And friction and radiation, ito yung na-waste nating energy sa pagtakbo na or rotate ng mga mechanical or mga dynamic energy. So, all of these are wasted energy. Wala ka na magagawa. So, waste na talaga yan. So, kung wala kang planong i-recover, ang gagawin mo na lang, wag mo nang pataasin tong waste energy na to. However, meron ngang heat recovery system. So with the heat recovery system, what we are trying to get is yung heat na nilalabas ng exhaust and nung radiator for water cooling. So upon evaluation, 2,507 kilowatt of heat is being exhausted. Sayang lang, lumalabas lang yon sa init through the fans of the radiator and the exhaust system. And you can see here, almost 500 degrees C. That big amount of energy ang nilalabas ng exhaust and 84 degrees C papunta sa radiator. So, ang computation basis namin during the study is 1 unit 4 megawatt diesel engine. Yun yung basis. So, what we have done is we have selected a chiller, an absorption chiller, which I will explain later. So, we installed a water heat exchanger na nadadaan yung heat papunta sa radiator before going to the cooling tower, and we have recovered 651 kilowatt of power. Then sa exhaust naman, naglagay din kami ng exhaust heat recovery boiler where we have recovered 1,900 kilowatt of energy. So with this, makakapag-generate yung heat exchanger namin of around 83.7 degrees C of hot water. So saan naman namin ginamit yon? As mentioned, we have installed an absorption chiller. So what is an absorption chiller? So actually, this is like a chiller system, an aircon system, a water system, aircon system, where you will just use hot water to generate chilled water of 7 to 9 degrees C. Imagine, ako, hindi rin ako makapaniwala, no? Meron palang ganung equipment during my time. So, hot water lang, and you can generate chilled water without electricity, without using any energy from compressors, di ba? Ang magagamit mo lang dito is pumping system. Yun lang ang additional cost, operation cost mo in terms of energy. So, bigyan ko kayo ng idea. Take note pala ha, ang ginamit namin nun is absorption chiller versus absorption chiller, yung B. Difference lang niya, silica gel to, lithium bromide ang ginagamit ng absorption chiller. Then, life expectancy rin, mas mahaba ang absorption and mas maikli ang absorption chiller. Then very simple ang operation ng absorption, complex ang absorption. So selection was made considering the criterion, operating characteristics and costs, maintenance, handling of media, reliability, and rate of return of investment. So ito yung medyo technicalities na absorption chiller. Bakit mas mahaba ang expectancy? Kasi yung media ng absorption chiller nasa surface lang ng media, silica gel. Unlike sa lithium bromide, ang absorption, ina-absorb niya. So talagang mas madaling masaturate yung media mo dahil nagkakaroon ng absorption instead of adsorption. So sa capacity curve din, pinag-aralan namin, yung absorption chiller, at saka yung absorption chiller, so if yung, di ba, umaasa lang kasi ang absorption chiller or heat recovery chiller, umaasa lang siya sa init na ibibigay nung chilled water na galing sa power plant. So pag bumaba yung init, may epekto yan of course sa chiller. So here you can see pag absorption chiller, di ba? If bumaba yung supply temperature ng water from 88 degrees C to 80 degrees, so yung absorption chiller magsha-shutdown na siya. So while yung absorption chiller kaya niya pang mag-operate at 90 degrees ng kanyang operating capacity. So kaya pinili rin namin yung absorption chiller. So with regards to flow rate, yung hot water flow rate, hindi rin masyadong nagbabago yung flow rate. Percent hot water from 50 to 150%. Ang galaw niya is from 95 lang refrigeration capacity to around 105 refrigeration capacity. So in case of varying load condition of diesel engine, yung variation of hot water flow rate makes only a small difference in chiller capacity, as shown in the graph. So ang operation, simple lang. So may dalawang chamber lang na palipat-lipat. So sa absorption chiller kasi and absorption or heat recovery chillers, so kailangan mo may dalawang chamber palagi, isa mag-absorb o mag-adsorb, yung isa naman magre-regenerate para magamit mo uli siya next time. So using a cooling tower or a radiator, yun yung tutulong sa regeneration process. Okay? So, yun yung medyo complicated na in-apply namin. Pero I would like to share to you yung isang practice namin na napakasimple at nakatulong din sa energy efficiency management namin. So, ito naman yung sa water treatment namin, effluent heat recovery. So, we have a water treatment. Actually, ito ay dahil sa, alam mo naman ng facilities, specialties yan. Yung isang technician ko, nagpapahinga sa tabi ng drainage ng water treatment system. Actually, he's an aircon tech. May dala siyang thermal device o temperature thermometer. So, napagtripan niya lang na kunan ng temperature yung effluent ng water treatment. And it turned out na 29 degrees C. So, nireport niya sa akin yun, sir, ang init pala nung temperature ng effluent o yung waste ng water treatment na dumediretso lang sa drainage. So, siya rin nagbigay ng idea na, sir, pwede kaya natin i-recover yon. So, naghanap kami ngayon ng re-recoveran. Yung factory namin, actually, yung air handling unit namin, ganito ka-intensive ang energy usage ng Toshiba. Yung factory air handling unit namin, ang return niya is 43 degrees C dahil sa ovens. So, kailangan naming ibaba yun into 12 degrees C para ma-supply uli back to the production. So, what we did, so from the water effluent, so gumawa kami ng mini reservoir. So, yung nakukuha naming temperature na 29 degrees, malamig yun, medyo malamig pa yun. So, pinump up namin sa air handling unit, which we have tawag dito, nag-fabricate kami ng pre-cooling system para daanan muna ng hot water coming from the production. So, bumaba yung hot water, yung hot air from 43 degrees to 35 degrees using just a small pump and a simple piping system. So, bago dumaan dun sa main coil ng air handling unit na sinusuplayan naman ng chilled water system. So, ito, may pre-cooling and repiping. So, 150 kilowatt na heat yung na-recover namin. So with this, so bumaba ngayon yung load in terms of chilled water supply namin. Bumaba yung load ng chiller namin. So some key points dito sa renewable or recovery. So recognize the wasted energy. So yun yung palagi rin nating pinag-uusapan sa energy management. So recognize it. Kung hindi nyo kasi alam na meron kayo na-waste, hindi magiging effective yung energy management nyo. So sa amin, yung diesel engine, malaki yung waste by literature and by actual, and yung effluent and other sources na pwede nyo makita. So recovery by recovery equipment, in our case, gumamit kami ng absorption chiller and HU pre-cooling system. So one of the neglected, the most neglected is the efficiency that you can get through maintenance. So always remember, our dirty equipment is an energy inefficient equipment. So sa amin naman, ang i-share ko sa inyo is how I applied ozone generation. So ito yung typical chiller setup na kanina pa rin dinidiscuss from Sir Charles. So we have the chiller, may condenser, may cooler, or the evaporator supplying chilled water. Dito naman yung condenser na kino-cool down or used for the to condense the refrigerant. So dumadaan ng cooling tower at meron pang blow down, di ba? And we have the pump. So sa chiller efficiency, di ba? Chiller efficiency always boils down to condenser. So kung meron kayong kung para ma-visualize nyo, yung outdoor unit ng split type refrigerator ng split type aircon nyo, yun yung condenser. So always, 'di ba? Clean condenser, 'di ba? Ang ideal metric ng ng efficient chiller. Pero sa chiller system na may cooling tower, so kailangan mo rin ng quality cooling water para ma-maintain mo yung clean condenser. So, ito ngayon, yung typical na ginagamit natin, chemical treatment and blow down. So, ito yung representation ng condenser. So, sa outdoor unit ng split type, ang mine-maintain natin yung labas. So, palagi natin mine-maintain na malinis yung labas. Pagdating naman sa chiller, yung loob ang dinadaanan ng cooling media natin, which is water. So, yung yung orange portion dito, ito yung copper tube nyo. So, in time, yung loob yung wall ng copper tube nyo, nagkakaroon ng scale, biofilm, sludge, and corrosion na yun ngayon na nagkukos ng inefficiency dahil yung transfer of heat na dapat papalamigin natin yung refrigerant natin, di ba? Yung refrigerant natin, binablock na ng mga scale, biofilm, and sludge and corrosion. So kaya tayo nagwa-water treatment and nagbo-blow down din. So here, when we studied 15% energy increase in a year dahil lang dito. So kailangan mo yan, pag tumaas na yan, ang mine-maintain namin before, mas conservative kami sa pinakita ni Engineer Noel. So sa kanya, 2.4 degrees Fahrenheit. Namin, less than 2 degrees C condenser approach. So, yan. So, ito yung typical, may chemical tank. So, lilinisin mo yung tubig. So, anti-scale, anti-algae, anti-bacteria, anti-corrosion. Ang daming types ng chemicals na ginagamit if we will be using the chemicals. So, operation cost na ito, affected of course because of the chemicals. Yung blowdown ng water mo kasi blowdown ka rin ng blowdown. And 3, yung condenser descaling mo because will always come a time na i-descale mo yung condenser mo. Kailangan mo pa ng downtime para magawa mo yon. So we ended up with our research, actually pinag-aralan ko ito ng 5 years bago namin kinonsider, installing an ozone generator. So ito yung ozone treatment system namin. So instead of using chemicals, yung ozone ang ginagamit namin to and mix with water to break down carbonate compounds and biofilm to prevent scale, kill biofilm producer to prevent corrosion and kill bacteria, and break down cells and compound of sludge deposit. So, yan, wag na natin ito. Ozone is a molecule consisting of 3 oxygen atom. Yan, wag na natin ganin yan. Okay? So, how do we generate O3? So, may electrode lang using dielectric. So, yung oxygen natin nagbe-breakdown to form a pre-oxygen. So, para mag-form siya ng O3 plus heat. Okay? So, ang installation lang yan, so magkakaroon ka lang ng looping piping na dadaan sa cooling tower para makuha mo yung water sa basin mo at idaan mo sa ozone generator, paikot-ikot lang. So, actual performance ng Toshiba before, ito yung approach namin. Umaabot kami na up to malapit na sa 6 degrees C approach. And after installation, ng ozone generator. So nag-maintain na siya. Gradual lang ang pag-increase niya sa target namin na less than 2 degrees C. So benefits, other benefits, zero chemicals, less handling, low blowdown rate. So halos hindi na kami nag-blow down, and minimize cooler descaling. So less downtime and cost. So key points dito, check on alternatives, ozone versus chemical treatment. Meron ding ibang mga techniques, yung electrode, depende sa water quality nyo. Bowl, merong bowl na kasama yung bola sa tubig. Merong brush na once in a while, binabrush yung loob ng condenser, and others. Maraming technology. So don't just be peg on chemical treatment. Kasi ang chemical treatment kasi, kaya actually ito, known facto sa industry. Kaya nag-chemical treatment kasi continuous yung benta rito. Continuous din yung commission kung sino man yung bumibili ng chemicals. So known fact sa industry. So hard benefits, savings on water, chemicals, and maintenance costs. So some small scale measure sa air conditioning, lighting, small package aircon. So sa compressed air system naman namin, so ito yung pinag-aralan namin. We have a heatless type dryer. Ito yung parang mga tower type na dryers. Pero pag inobserbahan niyo yung mga dryers na to, so nagpe-purge siya ng 20% ng gine-generate ng compressor. So ginagamit niyo lang yon para tanggalin yung na-collect niyang water dito sa desiccant. So ang compressor, 1 cubic meter per hour na generate mong compressed air is equal to 0.111 kilowatt. So what we did, so may mga heated type na absorption kami, absorption dryers kaming na source out. Comparing it with the 20% air purge, only 4% lang ng air purge ang kailangan mo. So using heat. So a savings of 16% less purge or 66,860 kilowatt hour per month. Diba? So opportunity for savings of additional equipment due to increase in capacity. So hindi na kailangan before, dahil sa laki ng purge namin, pag nag-expand ng production, kailangan mo rin magdagdag ng additional compressor. So with this, maliit lang yung purge, hindi na kailangan yung opportunity sa pagbili. Nadagdag pa dun sa break-even calculation natin. So lighting system, ito hindi ko na di-discuss because this is very typical. So ito, share ko sa inyo yung sa package type aircon. Aircon compressor controller. So ito yung maliit na device na nakikita nyo rito. So actually, ang ginawa lang namin dyan, pinag-aralan namin what time dapat tumakbo yung compressor namin to maintain the 26 degrees C room temperature na minemaintain namin sa loob ng building. So, and we ended up na pwede palang tumakbo 12 minutes, then patay ng 3 minutes. So, comparing it dun, kung umaasa ka lang sa controller ng aircon mo, or sometimes, continuous na tumatakbo yon dahil sa heat load mo. So, here, you can enjoy non-operating of the compressor within 24 hours ng 4.8 hours per day. So, sure savings to kasi talagang within a day, 4.8 hours na hindi tatakbo yung compressor mo. So, another one is a polarized refrigerant oil additive. Yung loob ng mga tube natin ng aircon, dumudumi rin yon because of oil, 'di ba? So, kumakapit yun sa gilid, like the presentation here. So, pag kumapal na yung kumapal, gaya ng in-explain ko kanina, nawawala na rin yung heat transfer ng refrigerant dun sa air na, 'di ba, sa mga split type aircon natin. So, merong PRO1 na tinatawag na refrigerant additive na pwede mong ilagay para dumikit siya sa wall ng copper tubing para yung oil mo mag-glide lang. Kasi yung oil, normal na sumasama yan sa refrigerant habang umiikot sa system ng refrigerant mo. So here, using polarized refrigerant oil additive, so 12% reduction in energy consumption. Okay, roof insulation. So the story here is actually may problema kami sa tulo nung building namin dahil matanda na. So there was mahilig kami sa research. So nag-research kami, ano ba yung pwedeng gamitin? Magpapalit ba kami ng bubong or merong some type of a coating na pwedeng gamitin para ma-eliminate namin yung tulo. And what we ended up, itong roof insulation, top seal yung brand. So this is the actual before and after nung after namin in-apply yung insulation coating. So from 50 degrees bumaba ng 30 degrees. Talaga nagre-reflect yung heat from the sun. So kaya yung punch list namin naghamon talaga yung contractor namin. No sir, we inspect around 2 PM hapon daw. And we will remove yung sapatos namin. Sabing gano'n. So, true enough, talagang kaya mong apakan in the heat of the day. So, and we have saved around 325 kilowatt hour per day on air conditioning. So, ito yung actual data namin. So, yung ceiling temperature namin nandito and room temperature bumaba talaga from this line before the application, bumaba yung room temperature namin. So, some unconventional. Ito yung mga sinashare ko sa inyo, yung mga unconventional. So, around 20% savings on air conditioning. Which initially, para sa tulo lang, naging savings pa sa efficiency. Kaya sinashare ko na sa inyo na pwede na natin gawing primary benefit yung energy savings sa pag-correct ng tulo ng bubong nyo. So, some small scale renewable. So, yung mga wala kaming ceiling na area, water treatment system, nagkabit kami ng solar tube. So, with this, so we increased the illumination from 40 to 90 lux. So, na hindi na namin ginagamit. So, patay na yung mga fluorescent lamp namin. Gabi na lang namin to binubuksan or pag madilim na talaga. So, it looks like this. So, marami nang available niyan. Around 250 kilowatt hour per month savings ang na-enjoy namin using this one, daylight utilization, or in our 40% savings. So, other renewable areas, so actually, nung naging energy manager ako, naging energy freak din daw ako. Kasi lahat na nakikita kong wasted energy, pinag-iinitan ko. So sa roof, sobrang init ng bubong, paano ko magagamit yon? Effluent, drain flow, ng mga aircon, ng mga condensate. Exhaust fan, di ba? Exhaust fan, bububuga ng hangin 24/7 sa mga manufacturing and production. Chilled water flow, umiikot yun 24/7. So, cooling tower blowers. So, may dynamic energy siya o may kinetic energy siya. Aircon condenser. So, yung mga tumutulo. Di ba? So, sa roof, ito yung mga, actually, hindi na namin natuloy ito, pero mga pwede nyo i-consider. Thermal power. So, application of absorption aircon. So, unfortunately, wala pa rin makitang high, para fast ROI na thermal power absorption aircon. So this one, siguro pinakaswerte nyo ng mga 8 years. Pero if you are really into social accountability side, so pwede nyo i-consider yung thermal power. So lagay nyo sa bubong nyo para ma-absorb yung init ng bubong plus yung solar radiation. Then wind power. So ito yung sinasabi ko sa inyo, di ba? Pag tinignan nyo yung mga exhaust fan, pwedeng takbo lang siya ng takbo, sayang yung energy nung flow rate nung hangin. So ito yung Bernoullis, tinatawag na Bernoullis turbine. So pwede niyo ikabit yan without blocking yung flow rate nung exhaust fan. So pwede kayo mag-generate ng maliit na energy. So what's this? You can use it for lighting sa mga machine rooms nyo, di ba? Or small energy. So something you can consider. hydropower, 'di ba, sa mga drain. So this is very available. Actually, pag tumingin ka sa Lazada, ang daming ganito, yung maliliit. You can use that. So sa mga drainage system nyo, pwede nyo siyang gawing mini hydro system o PICO, sabi nila, PICO hydro system. And you can even connect it in line with your chilled water system. Just make sure na hindi maapektuhan yung flow rate. Of course, pag may nagkaroon ng loss, energy waste din yon. So, pero the best practice na pwede yung best application is yung sa drain, yung papunta na sa drainage nyo or sewer system. Okay? And here, I would like to share to you some certification. So, some of you might know I am an AMAS certified, ASEAN certified energy manager. So, kami rin, during my time in Toshiba, kami rin yung kauna-unahang binigyan ng certification ng AMAS as an energy management gold standard. So, 3 lang kami na binigyan ito during our time. So, ito yung certification number namin, 002. Actually, it's supposed to be 001 ako. Kaya lang, ang kasabay namin is Baguio, TI Baguio. So, ang ginawa saka Mandaue, San Miguel, Mandaue. So, ang ginawa nung AMAS, sinimulan north, tapos tayo, Metro Manila, tapos south. So, kaya naging 002 kami. Sayang, sana kami yung 001 certification. And some awards. So, because of energy management, so we have received awards from the Department of Energy, Emilio Abello, na nakasabay ko rin si Pres Charles, 2008. And we have received the Hall of Fame Award. We have received the Secretary Award, the highest award given by the Department of Energy. And with this, we have also received the ASEAN Best Energy Management Practice and the ASEAN Best Energy project. Ito yung heat recovery system ko sa power plant. So lahat to na-receive namin during my time sa Toshiba. So ito yung sinishare ko sa inyo because some of you IIEE members na would like to go or pursue the energy management or energy practice. So ito rin, really, this is not just palakpak or baliwalang recognition. So I have been, it has been very beneficial sa akin, especially right now na nasa consultancy business ako. So talagang malaking tulong to. And siguro ito rin yung nagdala sa akin dito to be the Energy Efficiency and Conservation Chairman of IIEE. So some key points. So always remember, energy is all around us, not just waiting to be utilized. Diba sabi nga, energy can neither be destroyed nor created. Nandiyan lang yan. Focus on wasted energy. So nagkabaliktad pa. Yan, yung binanggit ko. Always know. Kaya sa energy management seminar ko, sinisimulan ko dito sa basic na to. Universal Law of Energy Conservation. Energy cannot be destroyed, cannot be created. It only transforms from one form to another. So, minsan nagiging heat lang, kaya nasasayang ang energy. You cannot improve but you cannot manage. Ito yung sinabi kanina ni Engineer Pabilona. You cannot manage but you cannot monitor. So, kailangan mo ng monitoring system. Kailangan mo ng metro. And sa bagong guidelines ng aligned to the RA 11285, required na a new installation. Hahanapin na to ng OBO sa permitting na kailangan if you are installing new, you will be installing or constructing new or applying permit for new installation. So, kailangan nyo na mag-install ng metering system. Ito, sinabi sa akin ng one of my participants during my DOE seminars before. So, simple lang yan, sir. Sabi niya, use your common sense. Tama nga naman. We use our common sense for energy efficiency. So, thank you very much. I hope you get additional inputs. May mga tanong ako nababasa? Yes?
Yes, sir. We have 3 questions po from the question and answer box po. I will read the question for you na lang po, sir.
Alright, okay.
Sir, first question is from Sir Hilton Val Budtan. Sir, do we coordinate also with the mechanical engineers regarding aircon works?
Yes, it is really a good practice to coordinate with mechanical engineers. However, if you really wanted to be an energy practitioner, kailangan alam mo rin 'to. So, don't be afraid to explore. Kasi ganito 'yan, ako proven ko 'yan, siguro mag-a-agree din sa akin yung ibang mga facilities guy dito. Mas madaling pag-aralan ng mechanical system kaysa electrical system. Kaya mas fit talaga sa ating mga electrical practitioner yung energy practice eh. So, study, research. From my presentation, yun yung gusto ko rin i-impart sa inyo or gustong inculcate sa inyo na research, study. So, benchmarking, sabi kanina rin, kailangan natin yun. So, yes, you can coordinate. However, aircon system is very simple system. So, pwede nyo ng pag-aralan.
Okay,
Thank
sir.
you.
Okay, sir. Next question is from Sir Michael Montefalcon. Sir, yung inverter pump po ba consider as energy and cost-effective po ba?
Inverter, yes. Kanina, in-explain ng maganda ni ni Engineer Charles Singson, ni Pres Charles Singson, di ba? So talagang proven na to na cube talaga. Yung sa presentation niya kanina, just reducing 20%, di ba? Pag ni-reduce mo ng 20% yung ng RPM mo or speed mo, ang savings mo is around 47%. So imagine that, 20% lang, 47%, almost 50% na reduce mo sa energy. So very effective to. Pero sabi ko nga, be cautious. Hindi lahat nilalagyan. Kung hindi variable o hindi binavary yung speed, hindi mo kailangan i-vary. Siyempre, of course, kung naka-full load din siya, sayang lang yung investment nyo. Thank you.
Okay po, sir. Third question is from Sir Remuel Sariola. Hi, sir. Regarding air compressor controller kanina, does it have any unwanted effect sa compressor since magiging on-off ang operation ng compressor? If meron po, how do you eliminate the impact on the compressor?
Actually, naging tanong din namin yan when we are studying. Pero kasama rin, hindi ko lang nabanggit kanina, kasama rin sa study namin kung ilang beses din nag-i-stop and on and off yung compressor during normal operation. So actually, ang difference lang niya is almost 10%. So, and based on our study rin, aircon compressor are made to start and stop talaga. So, kaya ng compressor yon. So, walang impact. And siguro, dadagdag ko na rin, meron din kasing nagtanong nung i-present ko yan, how about the starting current? So, yung starting current, tandaan nyo, almost 6 seconds lang. Comparing to the 20, di ba, 4.8 hours na save natin. So, 6 seconds starting current. Baliwala yun. Baka hindi nga gumalaw yung kilowatt hour meter nyo nun. Thank you.
Okay,
Tapos
sir, for...
Okay. Dagdag ko lang, if you may.
Yes, sir.
Doon sa, kaya yung right sizing ng receiver, napaka-importante, no? Very important yun. Ang best way to go about or test yung inyong receiver is to close yung mga supply galing sa air compressor. Huwag niyong gagawin ng kailangan ito, gagawin nyo with coordination with manufacturing or dun sa loads niyo. No? Para malaman nyo gaano kabilis bumaba yung pressure na wala yung compressor running. So doon yung pwedeng makita na okay, yung settling ng time between maubos yung laman ng compressor, nung receiver should be higher, higher, no? Higher dapat bago pumalo yung isang compressor mo. At size up siya doon sa load na malaki within the site, no? Ganun ang sizing nun.
Okay, thank you.
Okay, sir. Thank you also, Sir Noel. And for the last question po, Sir Perry, ito naman po from Sir Roel Bebero. Chairman Perry, anong brand nung air compressor controller? Thanks.
Actually, yung ginawa namin, fabricated lang namin yon. So kami lang mismo gumawa. Pero meron ako nakita Japanese brand, I think SSK. So medyo high-end na siya, may monitoring na, may alarm. Meron ka ng energy monitoring. So marami na sa market. Thank you, Pres Roel.
Okay po. So, for the Certificate of Appreciation, may we call on Brian for the citation.
Good afternoon. The IIEE Institute of Integrated Electrical Engineers of the Philippines Incorporated Energy Efficiency and Conservation Committee presents this Certificate of Appreciation to Engineer Christopher Villaflor for imparting valuable insights as resource speaker on the topic Best Energy Practice Electronic Manufacturing, given this 12th day of December 2020, Philippines. Signed by Rodrigo T. Picolera, 2020 IIEE National President. Thank you.
Okay, yes, we are now moving closer to the end of our program. And before ending this, may we call on again Sir Perry Villaflor for the Energy Efficiency and Conservation Committee report.
Okay, thank you again. So this will be very quick na. Okay. So thank you again for attending. So this is the committee report for 2020. So first, I would like to introduce to you the committee. So as mentioned, yours truly is heading the committee as chairman. Charles Singson, who presented earlier, is the vice chairman of the committee. So we have three members: John Christian Nicdao, Engineer Roland Vasquez, our NSEC, Engineer Castor Ison, and Alan Alvarez as our overseer. Okay? So we have conducted, even with this challenging times, we have conducted 10 meetings for the year. Two of which is face-to-face and virtual Zoom for the virtual via Zoom for the other meetings. So our milestone, actually we started as an RA 11285 enforcement committee, but we have requested to be given a wider coverage on energy efficiency, kaya nag-end up tayo sa Energy Efficiency and Conservation Committee. We have conducted the first TCPD seminar. So yung first TCPD seminar is energy management from our committee. We conducted the RA 11285 caravans sa nationwide and outside IIEE chapters. 11 counts in coordination with TCPDC also. We participated as a member of the technical working group on the revision of the guidelines on energy conserving designs on buildings. A technical also part of the technical working group on the revision of the green rating system of the Philippine Green Building Initiative. And the first now we are celebrating the first ever IIEE celebration of Energy Consciousness Month, as mentioned earlier. So these are some of the pictures. The first TCPD seminars, the first caravan at Northern Luzon Region Chapter Conference as part of the PGBI TWG and DOE TWG. So looking in the future, expect full support on RA 11285 implementation. As mentioned by Vice Chair Charles, sa April 21, mag-start na yung mga monitoring. So we will be supporting members na magiging energy practitioner on the registration on the first quarter of the year, and we'll be doing orientation on on the guidelines on energy conserving design on buildings. So we will be launching officially the IIEE Energy Practitioners Group. So all the practitioners, IIEE members na magiging energy practitioners, we will be having our own group na tayo rin yung tutulong sa energy EECC. So we will link try to link up with AFEO, the ASEAN Federation of Engineering Organization na nagbibigay ng ASEAN Energy Registry, AER, and to the ASEAN Center for Energy. So we will be exploring yung Certified Energy Manager and Certified Energy Conservation Officer certification program. So we will try to start up kung ano yung plans na pwede natin gawin para ang IIEE na mismo ang magbigay ng certification sa ating members. So award selection, we will be considering best energy practice din for an individual and for chapters, and outstanding IIEE energy practitioner. So we will be corroborating this one with the awards committee. And of course, hindi natin papabayaan yung national building natin. So we will try to make our IIEE national building sa Cubao na energy efficient din syempre. So isa 'yon sa mga plans natin for the next year. So maybe you are wondering, so our incoming national president, desidido na po siya na ako rin po ang maging chairman din ng EECC for next year. So binibigay ko na sa inyo yung plans. And for Energy Consciousness Month natin, thank you for the chapters and the regions na nag-support talaga. So some of the activities sa Metro South, as mentioned, kasabay nila Press Charles, meron silang energy seminar today din. PB seminars ng Metro East chapter. So yung official overlay natin, profile overlay natin. So maraming gumamit. Ang pogi ni Chairman Ferdinand. So sa CLC, nagkaroon kami ng mga info banners sa FB page namin para makita nila. Meron tayong pledge banners na kumalat din sa IIE Facebook. And merong ENMS seminar ang Northern Cavite chapter today din to. So sumabay din sila sa culminating event ng ating na ginagawa natin ngayon. So EECC has just started. Kasimula lang natin and a very good start. So there's more in store for you, all the members, lalong-lalo na yung magiging energy practitioner. Let us make energy efficiency and conservation an IIEE way of life. So, thank you. So, medyo minadali ko na ha, because of the schedule.
Okay, thank you very much po, Sir Perry, for that report. And now, before we proceed with the next part, which is the performance of Miss Lana Roy, is magra-raffle po muna tayo. And before that nga po pala, as you can see po sa chat box, sa chat box po ay meron pong sinend si Sir Brian sa atin na panibagong Zoom link po kasi po tayo po dito sa ongoing webinar ay lilipat po tayo dito sa kabilang meeting room and we're very sorry po for the inconvenience. But before we will transfer to the other Zoom meeting po is magpo-proceed muna tayo sa first part of our program and ang ira-raffle po natin ay yung 3 pieces na IIE in notebook with pouch and yung 3 pieces na gray IIEE polo shirt. So we will be using po yung sa name generator to be shared by Brian. Yes. So we have a total of 415 names. So dapat po ba Sir Brian ay nandito po sa meeting ngayon yung winners?
Yes, ma'am. Kailangan present po siya ngayon nanonood po.
Okay po. Sige po. So for our first winner ng IIEE notebook, Sir Eric Manansala. Yes, kindly raise your hand po, Sir Eric. Eric. Yun. Sir Eric is here po. Okay, so for the next one, next IIEE notebook, Junior. Ano to? JR. Meron tayong 6 na junior dito. Paano to? Sino to? Okay, we'll have to pick another name po. Erickson Bedia. For the second winner, kindly raise your hand po, Sir Erickson. Yes, Sir Erickson is here. And for the third notebook, Sir Benhor Adoptante. Sir Benhur is not here. Next. Sir Donnie Lagdamen, kindly raise your hand, sir. Yeah, Sir Donnie is also here. So for the next set of prizes, first is kindly pick a name. Sir Miss Jessie Respondo. Okay. Someone is calling. Okay. Wait. For the next name, Novo Tuazon. Next is Sir Zernan Joy Vertusio. Okay, Sir Zernan Vertus. Okay, Sir kindly raise your hand po, Sir I miss Zernan. Okay, don't wala po si Ma'am Zernan. Next. Okay. So, we will proceed with the next part of the program. Kindly transfer na lang po tayo dito sa link po na sinend sa chat box since this meeting will end po in 3 minutes. So, kindly copy na lang po yung link, ma'am and sir, and transfer na lang po tayo and we will proceed with the next part of the program po. For the winners po, kindly wait na lang po sa email and i-contact po kayo ng IIEE para po maipadala po yung prizes na napanalunan po ninyo. So, the meeting will end in 2 minutes po. Ilan ang naging winner natin? For the other 60 participants po na nandito pa po sa room, kindly transfer na lang po sa kabilang Zoom meeting po para sa next part of our activity.